Hello there, and welcome to Life Beyond Scene, where the world grows a little quieter, the edges soften, and the curious corners of our planet unfold at a pace that lets your thoughts drift without rush. Tonight we're going somewhere unusual, a place you can't stumble upon accidentally, a place so remote that even the waves themselves seem unsure what to do with all that emptiness. It sits far from any shore, far from flight paths, shipping lanes or casual explorers. It's a point in the ocean so isolated that if you were somehow standing there on a drifting vessel, you'd be closer to astronauts in orbit than to any human being on land. People call it Point Nemo, the oceanic pole of inaccessibility, the dead centre of the sea. But before we settle into the slow unfolding of what makes this place so strange, I'd love to know something simple. Where are you listening from tonight? Somewhere near a coastline maybe, or somewhere hundreds of miles inland. Perhaps it's morning for you, or late at night when the house has finally gone quiet. Wherever you are in the world right now, you're already far closer to other people than anyone has ever been to Point Nemo just by the comfort of being on land. If you find this kind of journey calming in its own way, or maybe a pleasant way to rest for a while, it would mean a lot if you liked the video or subscribed. It helps this small corner of calm reach others who might need a bit of space in their day, a place to let their thoughts untangle. And if it helps you drift a little closer to sleep, whether quickly or slowly, that's perfectly fine too. No pressure in any direction. Just let yourself be wherever you are, breathing evenly, letting your shoulders ease a bit as we begin. Point Nemo isn't a place most people ever think about. And honestly, why would they? The ocean is already vast beyond comprehension, and this particular location isn't marked by any island, any reef, or any sign that the water here is different from the water anywhere else. If you were looking at the surface, you'd see the same blue swells, the same shifting reflections, the same slow rise and fall you'd find in countless other stretches of sea. And yet, this point holds a kind of notoriety simply because of its distance from everything. There's something almost unsettling about that emptiness, a kind of quiet that doesn't belong to forests or deserts or mountains. Land at least gives you something to anchor your senses. Even in a remote wilderness, there are rocks, trees, footprints, something that reminds you the earth is beneath you. Out here, though, the nearest solid ground is hundreds of miles away in every direction. It's the kind of isolation that gives you a moment to think about how enormous our planet really is and how small we can feel in comparison. People often imagine the middle of the ocean as dangerous, or at least unpredictable. Storms rolling in without warning, waves towering like walls, wind cutting across the water in restless patterns. But the region around Point Nemo is surprisingly calm more often than not. The nearest continents are far enough away that weather systems tend to weaken before they reach this part of the Pacific. It's not that nothing ever happens out here, but more that things happen slowly, as though the ocean itself were stretching and yawning without much urgency. It's a place where the only consistent movement comes from currents that have been flowing, long before humans even knew they existed, looping through the South Pacific in wide arcs that never touch any coastline. And as strange as it sounds, this remoteness didn't stop Point Nemo from becoming famous for something almost ironic. Because nobody goes there. Because there's no one to disturb. Because the ocean here is as empty as anywhere on Earth gets. Space agencies chose this region as a sort of final resting place for their obsolete satellites and spacecraft. When objects orbiting Earth need to be brought down safely, the goal is to aim them at a location where falling debris won't harm anyone. Won't land on a town, a ship, or even a stray fishing boat. So for decades now, this lonely patch of Pacific has quietly collected the remains of machines that once circled our planet. Space stations, satellites, fragments of rockets, all guided down to splash into the deep at coordinates chosen specifically because almost nothing lives here, and nobody watches the sky waiting for them to fall. But we'll get to that part fully a little later. For now, it's enough to picture that moment far out at sea, where the horizon stretches in every direction without interruption, and the sky opens above you with nothing but air and blue. If someone were drifting at Point Nemo, the nearest person would not be on Earth's surface at all but in orbit aboard the International Space Station. That comparison alone is enough to make the mind pause. We tend to think of oceans as part of our world, connected to the places we live and the cities we build, but this particular location pushes far beyond that familiarity. In some ways, the astronauts circling overhead feel almost like the only neighbours you'd have. It makes you wonder what it would feel like to actually be there. Not just passing through on some imagined boat, but stopping and listening, if listening is even the right word for a place so distant that even the sound of other ships never reaches it. The ocean always has a voice, of course, but here it's steady, unbroken by anything except the shifting of water against itself. You could float there for hours, days, and hear nothing but the low murmuring of waves. There's no seabird calls, no engines, no echoes bouncing off cliffs or landforms. The stillness isn't quiet in the way a silent room is quiet. It's more like standing at the edge of something so enormous that your own thoughts are the loudest thing in your perception. It's strange how human beings react to environments like that. Some find them calming, the way some people find the desert calming. Others feel unsettled by the emptiness, the absence of landmarks, the lack of anything familiar to anchor the mind. If you've ever been in open water far from shore, you might know a little of that feeling. The way the horizon wraps you in a complete circle so wide that you can't tell if you're moving or still. The way the sky feels taller somehow, as though nothing restricts it. Out at Point Nemo, that feeling stretches into something else. Not danger exactly, more like a kind of detachment from everything you normally rely on to feel oriented in the world. The name itself comes from a character in fiction, Captain Nemo, a man associated with vast seas and a preference for isolation. It's fitting in its own way, not because the location is romantic or adventurous, but because there is a kind of quiet defiance in existing so far from anything people build. We like to place meaning on maps, celebrity on landmarks, but this place doesn't offer any kind of reward except the knowledge that you've reached the furthest point from any human shore. And maybe that's enough for some, or maybe it's more interesting simply because it exists at all. When scientists talk about Point Nemo, they often compare the region to a desert, not because it's hot or dry, obviously, but because it lacks many forms of life. Life in the ocean tends to thrive near coastlines where nutrients flow into the water from land. Coral reefs, kelp forests, shallow shelves. These are the places where fish fill the currents and ecosystems layer themselves in abundance. But out in the open ocean, especially this particular area, nutrients are too scarce to support much. It's not lifeless, but it is lean. The water is clear because there's so little plankton. The creatures that do live here are the ones adapted to scarcity, drifting or swimming through huge distances to find what they need. It's almost strange to imagine that a place so vast could be compared to a desert, but scale doesn't always reflect what the eye expects. A desert can be enormous, and yet much of it is empty of complexity. The same applies here. The ocean may stretch in every direction, but most of its inhabitants prefer regions where currents deliver a steady flow of microscopic food. Out at Point Nemo, that kind of abundance simply doesn't happen often, and perhaps that emptiness is part of what makes the place useful to space agencies and sailors alike. Nobody worries much about disturbing anything out here. Still, emptiness in nature is never truly empty. Even this region is part of the Earth's systems. The currents that loop around it play a role in global circulation. They shape the movement of water across thousands of miles. They distribute heat, carry drifting particles, and influence the weather in ways we often don't notice until we look at maps showing how interconnected the oceans really are. You wouldn't think that a point surrounded by nothing would matter in any significant way, but the ocean never operates as separate pieces. Every part influences another, even if it does so slowly and quietly. Imagine for a moment what it would feel like to approach this region by ship. Not a large vessel filled with cargo, but something smaller. something where the sound of water brushing along the hull is one of the few reminders that movement is happening. Day after day, the ocean would stretch around you unchanged. If you turned off the engine, the silence would fold in almost immediately. The sky at night would be clearer than most people ever experience, unpolluted by artificial light. Stars would appear undisturbed, thousands of them, bright enough to cast faint impressions on the water. And the knowledge that the nearest land in any direction was more than 1,000 miles away would settle over you in a way that doesn't quite happen anywhere else. We're used to the idea that even if you're far from civilization, eventually there's a road somewhere, a trail, a farm, a village. Even the most remote deserts and forests still connect to human pathways if you travel long enough. But this place resists that instinct. There is no hidden island, no reef rising unexpectedly, no lighthouse, only water, a consistency that stretches far beyond what the mind typically grasps. It's the ocean stripped of interruption, and somehow, despite all that, it became one of the most human-influenced places in the deep sea, simply because of the debris that falls into it from orbit. Not in a cluttered way you'd ever notice from above, but in the quiet accumulation of objects that once circled the planet. Machines built with immense precision, launched with careful planning, travelling thousands of miles above Earth, and then ending their journey right here in one of the planet's emptiest regions. There's something slightly ironic about it, the contrast between high technology and quiet ocean, but we'll explore that more as we go. For now, just imagine that slow drift of the ocean surface, the soft shift of wind that carries across water without hitting land, the sense of a place where even the idea of direction begins to feel optional. It's not a dramatic setting, not a place of storms or cinematic tension. It's ordinary water made strange by distance, and that distance shapes everything else we're going to explore as we continue moving through this story, letting each idea connect to another without rushing toward a conclusion, because the point of this journey isn't to arrive somewhere quickly, it's simply to move steadily, letting the details reveal themselves the way the horizon reveals itself when nothing interrupts it. The strange thing about a place like this is how little it cares whether anyone knows it exists. Most locations on Earth carry some trace of human presence, even if it's faint. A weather station tucked into a rocky ridge, a trail cut through a forest by hikers, a cairn placed by someone marking a path. Even places that feel wild still hold some quiet sign of footsteps, wheels, or hands that move through them. Out here, though, the ocean stretches in a way that makes the idea of a footprint almost meaningless. There's no sandbar where you could leave anything behind, no shoreline where a traveller might step out of a boat, no reef to climb onto, no rocks to rest on. The water rolls and folds endlessly, offering nothing stable enough to carry the mark of someone passing through. It's an environment shaped entirely by movement. Whatever touches it is carried away almost immediately, erased as quickly as it appears. That absence becomes noticeable the more you think about it. The world is filled with locations shaped not only by nature, but by layers of history. Cities built on older cities, roads following ancient paths, fields shaped by generations of cultivation. Even mountains that seem untouched often hold old carvings, ruins, or evidence of someone who once stood there long before. But the central point of the remote Pacific doesn't hold that kind of memory. Nothing remains in place long enough to accumulate meaning. The water is always shifting, rearranging itself in a way that refuses to preserve anything. It's not hostile, it's just indifferent. The phrase "no footprints" isn't only literal. It has to do with the way the environment resists offering even the smallest sense of familiarity. If you imagine yourself drifting through this part of the ocean, you'd notice how everything around you carries no hint of someone passing by the week before or even the day before. No trails in the water, no patterns left by boats, no floating debris accumulating the way it often does along coasts. The currents here carry things in wide loops that avoid the edges of continents. The few items that do appear tend to travel enormous distances before breaking down. Even the waves themselves don't carry the same rhythms you'd see near beaches or shorelines. Without land to shape them, they move in broader, slower formations. It's an odd thought that a place on Earth could feel younger because of how it refuses to preserve anything. Land constantly records what happens upon it. Soil layers stack, fossils form. Archaeology tells us stories buried under centuries of sediment. But the open ocean erases far more than it remembers. Even shipwrecks, unless they sink near shallower regions, vanish into depths where light doesn't travel and pressure crushes metal. What remains is absorbed by the environment until it becomes just another part of the seafloor, indistinguishable from anything else down there. This erasure is natural, not purposeful. It's simply the way the ocean works, continually reshaping itself, refusing to hold on to evidence of anything for long. In places where humans rarely go, it's common to imagine that the absence of people means the presence of something else. Forests might be filled with animal tracks or the echoes of bird calls. Deserts might show the trail of a lizard crossing dunes, or the pattern of wind shaping ripples across sand. Even the Arctic, harsh as it is, shows marks left by species adapted to its extremes. But out here, far from land, the emptiness doesn't get replaced by another story. There's no bustling ecosystem at the surface, no clusters of birds nesting on cliffs, no sounds except the ones created by water and wind. Creatures exist below, of course, but they live in a world so detached from the surface that their presence never breaks through unless they breach or drift upward. Even then, sightings are rare. Most life forms prefer regions where food is more abundant, and this region lacks the nutrients that make other waters thriving. The more you picture it, the more you understand why researchers sometimes refer to this zone as oceanic desert. It doesn't resemble a desert in appearance, of course. There's no sand, no heat shimmer, no cracked earth, but it shares a similar simplicity in how it limits what can survive here. Nutrients typically come from coastlines, river runoff, and upwelling zones where deeper water rises. Those processes rarely occur at this location. Instead, the water cycles through a loop that starves itself gradually of what most marine organisms need to flourish. The result is a stretch of sea that seems too large to be so empty. Yet humans, being humans, always try to compare things to something familiar. We're used to landscapes giving us landmarks. Even a completely flat plain offers the occasional tree or ridge. The ocean here offers nothing equivalent. Look west, and the water stretches on. Look east, the same. North or south, no change. It's the kind of setting where you could spin in a slow circle and see no difference in any direction, no hint of where you came from, where you're going, or where anything else might be. That's part of what makes it difficult to wrap the mind around. Most of us rely on the simplest signs to orient ourselves. A building in the distance, the slope of a hill, the angle of shadows. Without those cues, the mind starts searching for something to hold on to. If you imagine someone drifting here alone, the lack of reference points would change their sense of distance. You could move miles without feeling like you were moving at all. The horizon would remain exactly where it always is, far enough away that your eyes can't track the change in position. Even the sky would seem unusually consistent. Clouds in this part of the Pacific tend to form and dissolve with the same slow patience as the sea, and storms develop far from land in ways that don't follow the dramatic patterns we often see near coastlines. Everything feels spread out, distributed across an area so big that even significant events feel diluted. That lack of variation creates a kind of stillness that's difficult to replicate anywhere else. On land, stillness often means quiet surroundings. A calm forest, a silent valley, a room away from noise. But the stillness in the middle of the ocean isn't about silence alone. It's about a lack of detail. Nothing intrudes. No distant vehicles. No animals calling out. No human structures breaking the horizon. just a repetitive, gentle motion that goes on and on without pause. Even ships avoid the area, not because it's dangerous, but because there's no reason to travel through it unless absolutely necessary. The major trade routes don't come anywhere near. Fishing vessels stay close to productive waters. Recreational boating rarely ventures this far. Everything about its location ensures that it remains free from human patterns. This leads to an interesting realization. Most places on Earth are either shaped by natural forces or shaped by human presence. This area, however, is shaped mostly by absence. Its defining feature isn't a mountain, a reef, a valley or a trench. It isn't a storm belt or a convergence zone. It's simply a point so far removed from everything else that the ocean around it has become its own kind of solitude. Not dramatic solitude, the sort you see in stories about explorers, more like the kind that happens when no one ever had a reason to arrive or leave. Even the act of measuring its position was an exercise in defining distance more than place. When researchers identified its coordinates, they weren't mapping a landmark. They were identifying a location by calculating how far it was from the nearest land in all directions. The moment you define it, you realize that it only exists conceptually. The water at those coordinates today won't be the same water tomorrow. Currents will have carried it elsewhere. But the point on the map remains, represented by numbers rather than anything physical. If you were to look down into the ocean at those exact coordinates, the depth below varies somewhat depending on currents and long-term geological shifts, but the general figure remains thousands of meters deep. Whatever sits down there is beyond the reach of sunlight and nearly impossible to explore with typical equipment. Because very little life exists near the surface here, the water is clearer than in most regions of the Pacific. Sunlight travels deeper before fading. That gives the area a strange visual quality. If you looked over the side of a boat, the depth would almost seem endless. There are parts of the ocean where plankton make the water murky, or where sediment clouds the view, or where fish and other animals create movement. Here the clarity can be almost unnerving. It's not transparency in the way tropical shallows are transparent. It's a kind of vast openness where your eyes travel downward until the blue simply becomes too dark to distinguish. The lack of footprints extends far beyond the surface. The deep ocean in this region is one of the least explored areas on the planet. Not because scientists don't want to explore it, but because the logistics involved in sending equipment to such a remote region are challenging. Research vessels require support, and support requires proximity to ports, supply lines, and safety measures. When you're more than 1,000 miles from the nearest landmass, every operation becomes complicated. Fuel, food, communication, navigation, all of it becomes a matter of careful planning. As a result, these waters remain lightly studied. The sea floor, likely quiet and covered in dark sediment, holds countless details we haven't seen yet. Any traces of the spacecraft that fell here sink quickly and settle into depths where light never travelled in the first place. In a way, this lack of human touch has preserved the character of the region. While other parts of the ocean show signs of change, driven by climate effects, pollution, and shifting ecosystems, this region's remoteness insulates it somewhat. It's not immune, but it sees less direct impact. There are fewer contaminants carried here by runoff, there's less disturbance from fishing and shipping. Even plastic debris, which unfortunately shows up nearly everywhere, takes longer to reach this part of the world. It doesn't mean the region is pristine, just that the scale of human impact arrives differently here, in slower, more diffuse forms rather than concentrated ones. Sailors throughout history rarely spoke of this part of the ocean because they almost never travelled close to it. Oral traditions from seafaring cultures often focus on coastlines, islands, storms, or fishing grounds. This location doesn't fit into those narratives. It never provided resources, shelter, or navigation markers. It existed outside the routes that mattered. Even modern oceanographers, who study currents and global circulation patterns, mention this area primarily for its emptiness rather than for specific features. When something is known mainly for what it lacks, it becomes difficult to categorize. Yet that absence is what makes it interesting. If you were to drift here long enough, eventually you would begin noticing tiny details that don't stand out at first. The way the colour of the water shifts with the angle of the sun, the pattern of small waves forming and breaking without any rhythm imposed by land, the occasional presence of far-travelling seabirds that wander incredible distances before moving on, the sound of the wind changing pitch depending on its direction. These quiet details remind you that even a place without footprints is still part of a living world. It just operates with fewer interruptions, and that continuity leads naturally into the next part of our journey, where this same oceanic isolation shapes not just the surface, but everything drifting beneath it, giving us a clearer picture of what fills the space where nothing seems to take root. There's something quietly unsettling about the idea that a single set of numbers on a map can represent the most isolated point on the entire planet. Coordinates usually feel like something practical, a tool for navigation, a way to locate a city, a mountain, or a stretch of coastline. They give shape to a world we understand. But the coordinates that mark this particular spot do the opposite. They point to a place defined entirely by distance, a location where the nearest pieces of land sit so far away in every direction that they barely feel real. When you read the numbers on a screen, they look ordinary enough, just degrees of latitude and longitude, yet what they represent is extraordinary. Point Nemo sits at roughly 48 degrees south and 123 degrees west. That combination doesn't conjure images the same way other famous coordinates do. There's no landmark attached, no recognizable feature, no historical event tied to it. It's simply a marker floating in a part of the Pacific that stretches wider than most people ever imagine. When oceanographers first calculated it, they weren't searching for beauty or mystery. They were looking for the mathematical point farthest from any landmass. The result was a location that seems almost like an oversight of geography. A region so empty it feels as though the Earth forgot to place anything there. If you imagine approaching those coordinates, it wouldn't feel like crossing into a new environment. There's no visible sign that you've arrived. The ocean doesn't change colour. The air doesn't shift dramatically. The sky doesn't open or tighten. The water, the wind, and the horizon remain exactly as they were miles before. That's the strange nature of it. You reach the loneliest place on Earth without knowing you've reached anything at all, except for the knowledge that everything around you is as far as possible from the comforting solidity of land. On maps, the continents surrounding this point look almost like parentheses holding it loosely. To the north lies the coastline of Mexico, to the northeast the Galapagos, further east the islands near Chile, to the southwest a remote part of Antarctica. None of them are close, not in any meaningful sense. The closest land mass is more than 1,600 kilometres away. If you tried to imagine that distance, it's like travelling from one side of a large country to the other, without ever touching ground or passing anything but water. It's important to remember that humans didn't set out to find this spot out of curiosity alone. The concept of an oceanic pole of inaccessibility came from the desire to understand global distances in a more systematic way. Just as the most remote points on land can be identified, the most remote point in the sea can as well. But once identified, it took on a personality of its own simply because of how extreme its isolation is. Even the name, borrowed from a fictional nautical wanderer, frames it as something belonging to stories and wonder, rather than mere geometry. If a person were to drift here, the lack of proximity to land would affect more than just physical distance. It would alter their sense of scale. We're used to thinking of the world as interconnected. Flights crisscross the sky, ships travel along routes, satellites orbit overhead. But at these coordinates, the connection feels thinner. The sea around you becomes something different when you realise there are no ships expected to pass nearby. No air routes overhead except for the occasional distant one that remains invisible from the surface, and no structures anchored to the sea floor. Even communication signals weaken in significance simply because there is nothing around that depends on them. In most places on Earth, even remote places, the idea of rescue, assistance, or contact is only a matter of time. Here it becomes a matter of possibility. Distance shapes what is feasible. A ship would take days to reach this region, even if it departed immediately after receiving a distress call. Weather, fuel, and navigation would play roles in slowing that response. That doesn't mean the place is dangerous by default, but it does highlight how far outside normal human reach it is. This raises an interesting distinction. Isolation isn't always about danger. Sometimes it's about the sensation of being unobserved, untouched, and unconnected. At these coordinates, the surface of the ocean becomes something like a blank page. Nothing interferes with it. No lights shine across the waves at night. No engines rumble in the distance. No cities glow on the horizon. The ocean feels larger here because nothing counters its size. There are no mountains to break the skyline. No island silhouettes to offer scale. You could travel in any direction for days and see no sign of change. This has led some people to describe Point Nemo as a kind of anti-destination. You don't go there to find anything. You go to see what nothing looks like, and even then, you won't find true nothingness. The ocean always contains movement, subtle shifts, tiny variations in colour and temperature. But compared to most parts of the world, this location offers fewer features to mark time or distance. The vast emptiness also influences how the sea behaves. The currents do not crash against rocks or redirect around peninsulas. They continue in sweeping arcs that circle through the South Pacific. These large circular flows, known as gyres, gather water into stable loops that maintain their patterns for years. Within them, the ocean surface becomes relatively calm, not because nothing moves, but because everything moves together. Wind still shapes waves. Storms still form from far away. But the underlying structure remains steady. This steadiness is part of why the coordinates feel so lonely. Movement without interruption can create a sense of detachment, a rhythm that doesn't break or shift the way coastal waters do. Near land, the ocean responds to geography. It changes shape as it crashes against cliffs or washes over beaches. It shifts direction when river water mixes in. It accumulates foam, algae, or drifting wood from nearby ecosystems. Out here, the water carries only what arrives from far away. And because so little life thrives near the surface, the sea feels aged but unmarked. If someone were to look around while floating directly on those coordinates, the experience would be defined largely by absence. No boats, no birds, apart from the occasional wanderer that accidentally crosses the area while travelling between distant feeding grounds. No dolphins or whales breaking the surface regularly. Most marine mammals follow patterns connected to coastlines, food sources, or routes that don't bring them near these waters often. The few creatures that do travel beneath the surface don't leave visible hints of their presence. Deep-dwelling organisms move quietly through the dark, far below where sunlight reaches. Schools of fish tend to avoid these nutrient-poor waters. Plankton populations thin out drastically. The ocean becomes a kind of quiet suspension, a vast column of water layered above an equally vast seafloor that holds its own mysteries. When people imagine remote places, they often picture mountain peaks or icy tundras. Those places feel remote because they challenge the body with harsh conditions. Point Nemo challenges the mind instead. It presents an environment where scale overwhelms familiarity. You could turn slowly in a complete circle and see no variation. It's easy to lose the sense of direction when everything looks identical. The compass becomes more useful than the eyes, not because the ocean is confusing, but because it simply offers no visual anchors. And yet, this location isn't empty of meaning. The loneliness of its coordinates becomes a kind of symbol, a reminder of how enormous the planet is beneath all the systems, technology and connections we've built. Most of us live in environments shaped heavily by human design. Roads, buildings, lights, schedules, even natural locations near cities carry signs of human influence. A place like this stands in contrast. It feels untouched, not because people haven't visited it, but because the ocean refuses to hold their presence. Some researchers describe Point Nemo as the closest thing Earth has to a truly neutral location. No one has claimed it. No one has built anything on it. No cultural stories originate here. Its existence is purely geographic, and that purity gives it a strange significance. It reminds people that much of Earth remains inaccessible, not because it is hidden or protected, but because there is no reason to go there. The few times humans have approached these coordinates intentionally were for scientific curiosity or navigational challenges. Sailing vessels occasionally decide to cross this region simply to experience the emptiness, but they don't linger long. The ocean's vastness makes prolonged stays impractical. Supplies run low, weather shifts unpredictably, and the knowledge that help is distant encourages movement. When people describe how they felt drifting near these coordinates, they often use words that reflect the difficulty of processing the scale. Some mention that the sea felt featureless in a way they had never experienced. Others describe a sensation of being suspended in place, as though the world had stopped moving around them. A few say the experience made them feel unanchored, not in a frightening sense, but in a way that made them rethink what it means to be located somewhere. Because in most places, being located somewhere implies being near something, a building, a continent, a landmark. Here, being located somewhere means being far from everything. The meaning flips. Distance becomes the defining characteristic, not proximity. And that shift alters how the mind interprets space. There's an interesting detail to consider. At these coordinates, the nearest humans are usually not on the planet's surface but orbiting far above it. The International Space Station circles Earth at a distance of around 400 kilometers. Meanwhile, the nearest land lies more than 3 times that distance from the ocean's surface here. It creates a strange situation where the closest neighbours to anyone at this point would be astronauts travelling at thousands of kilometers per hour through the vacuum of space. It's not the kind of proximity most people imagine when they think about being alone on the ocean. This contrast between sea level isolation and orbital proximity highlights something profound about the way Earth functions. We're used to thinking of the planet as a surface dotted with cities, forests and oceans. But in reality, the sphere extends upward and downward in ways that make the surface feel thin. At Point Nemo, the thickness of that thin layer becomes more obvious. You feel surrounded not only by water, but by an enormous volume of space that stretches above and below in equal measure. Below the waves, the ocean floor sits thousands of meters deep. That seafloor is shaped by geological forces that operate on timescales beyond human measurement. Undersea ridges, sediment accumulation, volcanic activity and shifting plates create landscapes that almost no one has seen. Even specialized equipment struggles to map these regions in high detail because of the distance required to reach them. Down there, the pressure is immense, the darkness complete. Life exists, but in forms and densities very different from the vibrant ecosystems found in shallower waters. Above the waves, the sky seems wider than in most places simply because nothing interrupts it. Clouds stretch uninterrupted for miles. Sunrises and sunsets paint wide swathes across the horizon. Stars fill the sky without competing against artificial light. Even the moon feels brighter when its reflection stretches across a surface so empty of human interference. The combination of these elements creates the sensation that the entire environment at these coordinates is defined by scale. Everything feels bigger, not because it actually is, but because nothing breaks the continuity. Human presence in most parts of the world creates boundaries. Here, boundaries dissolve. If someone were to stay here long enough, they might begin noticing how their thoughts slow. Not in a languid or drowsy way, but in the sense that there's nothing to push against. Cities encourage quick thinking. Coastlines encourage alertness. Forests offer stimuli that shape attention. But here, the environment provides no tasks for the mind to latch onto. It's the kind of stillness that gives space for reflection, even if that reflection arrives simply as a quiet awareness rather than deeper understanding. And that awareness shapes the next part of this journey naturally, because understanding these lonely coordinates means paying attention to the emptiness surrounding them, an emptiness that doesn't represent a void, but something the ocean maintains through distance alone, giving us more to explore as we continue moving forward through this quiet space. There's an odd clarity that settles in once you start thinking about what defines this part of the ocean. Not excitement, not danger, not even beauty in the usual sense. Instead, it's distance, silence, and salt. 3 characteristics that don't sound dramatic on their own, but together create an environment different from almost anything else on the planet. Most places earn their identity through what they contain. This place earns it through what it lacks. The longer you sit with that, the more you start to understand why it fascinates people, even though so few will ever see it. Distance itself plays a larger role here than anywhere else on Earth's surface. Not the kind measured by footsteps or car rides, but the kind defined by thousands of kilometres of uninterrupted ocean in every direction. It's distance that doesn't change quickly. If you travelled for hours, you'd still feel almost exactly the same space around you as though you hadn't moved at all. There's something about that type of distance that alters how a person thinks. Most environments give us reference points. A tree line, a ridge, a building, a shoreline. Something that breaks up space so we can measure our progress unconsciously. Here, that doesn't happen. You have no sense of approaching anything because there's nothing to approach, nothing to recede from, nothing to help the mind track where it has been or where it's going. If you try to imagine this environment, it's important to picture how the sea behaves when it's free from the influences of land. The waves don't crash against cliffs or curl along beaches. They move in larger, slower patterns that travel long distances without breaking. The energy isn't interrupted, so it spreads evenly, giving the surface a steady pulse rather than the irregular rhythms seen near shore. If you were floating there, you'd feel that consistency. The water would lift and lower you at intervals that feel almost predictable, not because they're gentle, but because nothing disturbs them for such long stretches. That steadiness might seem calming, but it can also be disorienting simply because it removes the usual clues that tell you how far you've drifted. Silence is another defining element, though it isn't silence in the sense of total absence of sound. The ocean is never truly silent. There's always the sound of wind moving across the surface, the creaking of a vessel, the low rumbling of distant waves. But out here the silence is shaped by what's missing. There are no voices calling across decks, no engines humming from nearby boats, no gulls circling overhead, no splashing from animals feeding near the surface. Most seas carry a kind of background noise from human activity or wildlife. This region doesn't. What you hear is limited to natural movement, and even that feels subdued because everything spreads out over such an enormous area. People who have sailed near these coordinates sometimes describe the soundscape as thin, not in a poetic way, but in a literal one. The sound doesn't bounce back at you. On land, even in quiet places, noise reflects off surfaces. A forest traps sound among trees. A canyon amplifies it. A city creates layers of echoes. The ocean usually reflects sound off waves or cliffs, but in this region, the reflections dissipate quickly because nothing holds them. There are no nearby landforms to shape acoustics, so the sound fades instead of returning. That gives the environment a kind of openness that's hard to describe unless you've experienced it. The silence also affects how people perceive movement. In many places, movement creates noise with every shift. Footsteps crunching, water splashing, wind rushing, structures creaking. Here, the sound of movement gets swallowed. Even the wind, if it's moderate, spreads its noise so broadly that it feels like part of the background rather than a distinct presence. That can be unsettling at first. When we hear less, we instinctively start searching for explanations. But after enough time, that instinct fades, replaced by a steady awareness of how the environment differs from familiar ones. Salt, the third defining feature, might seem obvious. It's the ocean, after all. But the concentration of salt and the way it interacts with the environment here is more significant than most people realise. This region is part of a vast gyre, where evaporation rates and low rainfall maintain higher salinity at the surface. The water feels slightly heavier, slightly denser. That extra salinity affects the way light travels through it, the way sound passes through it, and the way organisms survive within it. Salt acts as both a physical property and a barrier. It limits what types of life can thrive here, shaping the ecosystem in subtle ways. The water's salinity also changes how it interacts with the atmosphere. Evaporation increases in this part of the Pacific because the air above it is relatively dry and stable. That means more moisture leaves the surface and rises upward without being replaced as quickly by freshwater sources like rivers or rainfall. Over time, this creates a distinct profile in the water column, one that oceanographers can detect easily. While it doesn't cause dramatic visual differences, it shapes the entire biological and chemical structure of the system. Distance, silence, and salt together create an environment where the usual markers of life fade into the background. There's no burst of activity near the surface, no coral structures rising from below, no communities of large animals passing through with regularity. The few forms of life that inhabit these waters do so quietly and sparsely. Microorganisms drift in small numbers. A few species of fish travel through but don't stay long. Even plankton blooms, which colour vast stretches of the ocean in other regions, are rare here. The lack of nutrients prevents them from forming sustained populations. This sparse life affects the entire food chain. Without plankton, there are fewer small fish. Without small fish, larger predators don't linger. The absence of life doesn't mean the ocean is dead. It simply means it operates on a scale and at a pace different from what most ecosystems demonstrate. Instead of vibrant, layered communities, the region feels muted. Every form of life here exists at a lower density. That thinness reinforces the sense of isolation at the surface. When people talk about this part of the ocean, they often focus on what's above, the open water, the sky, the horizon. But the vastness below is equally important. The seafloor in this region sits thousands of meters down, far beyond the reach of sunlight. Down there, the pressure is immense. Even the hardiest deep-sea creatures struggle to survive in significant numbers. Sediment collects slowly, carrying whatever organic material drifts down from the surface. Because so little life exists above, even the deep-sea ecosystem remains sparse. Despite this, the deep is not uniform. The seafloor contains mountains, valleys and ridges created by tectonic activity over millions of years. But since there are no hydrothermal vents or nutrient-rich upwellings here, those geological features remain uninhabited in the way that other deep-sea environments attract unique species. It's another example of how absence shapes the character of this location more than presence does. Distance plays another role too. It isolates this region from human activity not just physically, but culturally and historically. Most places with long stretches of ocean between them become significant because they connect continents or trade networks. But this region sits between nothing. It isn't a gateway to anywhere. Ships don't need to pass through. Explorers of earlier centuries didn't map it because it didn't lead to valuable routes. Even modern satellite imagery often focuses attention on coastlines, storms, and populated areas. The empty centre rarely draws interest unless something unusual happens there. Yet the very lack of attention becomes its own point of curiosity. People find themselves wondering what a place looks like when nothing draws them toward it. What the air feels like. What the water sounds like. What thoughts rise to the surface when all distractions fall away. When you imagine floating at those coordinates, the environment forces you to confront how much of the world's identity is built around access, connection, and activity. Here, those factors disappear. What remains is the raw condition of a place untouched by anything except natural processes. The silence becomes more than a lack of noise. It becomes a condition where thoughts settle differently. With no external markers, the mind may begin to search for internal ones. People might become more aware of their breathing, their heartbeat, the sound of clothing moving when they shift their weight. In some ways, the environment feels similar to being in a room with the lights off, except the room is thousands of kilometers wide and the darkness isn't literal. It's the darkness of not having anything to hold on to visually or mentally. There is also the matter of how time feels here. Time in remote environments tends to stretch or compress depending on how much stimulation the mind encounters. In busy environments, time often feels faster because attention remains directed outward. In quiet ones, time slows because there's nothing to distract the mind. Out here, the combination of steady waves, unbroken horizons, and sparse stimuli gives time a different texture. Minutes feel longer. Hours feel harder to measure. Without visual variety, the day's progression seems slower, even as the sun moves steadily across the sky. The salt-laden air affects perception as well. It dries quickly on the skin, leaves a thin taste on the lips, and clings to clothing. Over long periods, it can make a person more aware of the environment simply because it interacts continuously with the senses. The smell of salt becomes stronger when there are no competing scents. That monotony focuses attention inward again, reinforcing the feeling of being suspended in a place where the usual sensory balance doesn't apply. The sky contributes to this sensation more than people expect. Without mountains or buildings to interrupt it, the sky forms a dome that stretches down to the horizon in every direction. On clear days, it feels enormous, wider than usual simply because your eyes aren't accustomed to seeing so much uninterrupted space. On cloudy days, the entire world seems wrapped in a soft, uniform grey that blends seamlessly into the sea. Even storms behave differently. Instead of rushing in quickly from behind terrain, they form gradually or move gently across the water. Their approach is slower, more telegraphed, but still powerful. All of this shapes a location where distance becomes the defining factor in every direction. Distance from land, distance from human presence, distance from geological features, distance from biological richness. The silence that settles over it is a natural result. Not silence from the absence of sound, but silence from the absence of variation. And the salt in the water and air becomes the constant that ties it all together, shaping the physical environment from the surface down to the seafloor. If someone were to stay there long enough, they might begin to appreciate how the place functions without reference to human purpose. It doesn't exist to challenge, comfort, frighten, or inspire. It exists simply because Earth's geography and ocean currents shaped it that way. Its identity is a reminder that the planet contains regions that sit outside human expectation. It isn't hostile, but it isn't welcoming either. It simply is. And as the thoughts settle around these realizations, the next part of the journey begins to take shape naturally, because everything that makes this place distant, quiet, and saline also helps explain why its emptiness has practical uses, and why the objects humanity sends into space eventually return here, giving us more to follow as the narrative continues. When you think about the open ocean, the first images that come to mind are often filled with life. Schools of fish moving in coordinated shapes, whales rising to the surface for air, birds circling overhead, coral reefs full of activity, coastal waters rich with movement and colour. It can be surprising to learn that a huge part of the world's largest ocean contains almost none of that. Not because it is dangerous or extreme in temperature, but because it doesn't give life what it needs. The emptiness around this remote location isn't mysterious once you look closely at the conditions. It's a region where almost everything required for biological abundance is absent, even though the environment itself appears calm and unchanging. The first and most important factor is the lack of nutrients. Life in the ocean, especially near the surface, depends on tiny organisms that produce energy from sunlight. These microscopic forms of life, usually phytoplankton, are the foundation of the marine food chain. They take in sunlight and carbon dioxide, combine those with nutrients in the water, and create energy in a form that other creatures can eat. Without them, everything above them in the chain begins to thin out. This part of the South Pacific is known for being extremely low in nutrients. Not just low compared to coastal regions, but lower than almost anywhere else on Earth's surface. Oceanographers sometimes refer to areas like this as marine deserts, not because they resemble deserts visually, but because they lack the basic resources needed for life to thrive. The key nutrient that shapes most ocean ecosystems is nitrogen, followed closely by phosphorus and iron. These elements usually enter the ocean through rivers, rainfall, atmospheric dust, and upwelling from deeper layers. But here, none of that happens at a meaningful scale. There are no rivers feeding water into this part of the ocean, because the nearest land is thousands of kilometers away. Rainfall is limited by the stable air mass that sits over this region. And the deep water rarely rises to the surface, because the gyre circulating through this part of the Pacific pushes everything downward in a slow spiral, locking nutrients below the top layer. This layered structure, created by temperature and salinity differences, prevents the deeper, nutrient-rich water from mixing upward. In many parts of the world, colder water rises along coastlines, or in areas where currents shift. That motion brings nutrients up from the dark depths. Here, the circulation has the opposite effect. The surface water stays on top, the deeper water stays below, and the organisms that would benefit from nutrient mixing simply don't get what they need. This creates what scientists call oligotrophic water very low in nutrient content. If you measured the concentration of essential nutrients here, you'd find numbers far lower than those in coastal waters or areas where ocean currents collide. Because the surface layer is so stable, phytoplankton populations stay small. They produce just enough to sustain a few species, but not enough to create an abundant food web. With so few phytoplankton, zooplankton populations also remain sparse. Fish that rely on those smaller organisms pass through occasionally, but they don't stay long because the environment cannot support large numbers of them. It's not that the water is hostile, it simply offers very little. A small number of highly adapted microorganisms survive here, but the large diverse ecosystems people think of when imagining ocean life don't develop. The environment is like a pantry with almost nothing on its shelves. Any creature passing through has to keep moving or risk running out of food. The clarity of the water is another clue. Clear water is often associated with beauty, particularly in tropical regions. But extreme clarity in the open ocean usually means a lack of life. In regions full of phytoplankton, the water takes on a greenish or cloudy colour because of the density of tiny organisms floating in it. Here the water is so clear that sunlight penetrates unusually deep, sometimes reaching more than 100 meters below the surface. That depth of light penetration tells scientists that very few organisms are blocking the light, or absorbing it. Clear ocean water doesn't mean healthy or vibrant, it means empty. The stability of the gyre plays a part as well. The currents in this region move slowly in a circular motion, trapping the same water for long periods. Over time, this motion isolates the water from the rest of the world's oceans. Fresh nutrient sources rarely enter. Instead, the water inside the gyre grows increasingly depleted, and because the motion is so broad and slow, it doesn't churn nutrients upward the way turbulent waters do. The result is long-term nutrient starvation at the surface. Without food sources, surface-dwelling animals don't linger here. Birds prefer areas where fish gather near the surface. Whales follow patterns shaped by prey availability. Dolphins like regions with high activity or strong mixing zones. Even large predatory fish depend on areas where smaller organisms concentrate. None of those conditions exist here, so the creatures most people associate with ocean environments simply don't appear often. Below the surface, the story is similar. Deep-sea creatures survive on organic matter falling from above. When phytoplankton thrive near the surface, some of their remains drift downward, feeding organisms in the dark. But in this region, so little organic matter is produced at the top that the deep sea receives only a thin supply. The creatures that live thousands of meters below survive, but at much lower population densities. The sediment here accumulates slowly because there isn't much falling into it. Another factor shaping the emptiness is the region's position relative to global wind patterns. The winds that blow across the Pacific help move nutrients and airborne particles. But the stable atmosphere over this central location doesn't deliver as much material as other areas receive. Dust from continents, which often serves as an important source of iron for ocean ecosystems, rarely reaches this far. Without iron, phytoplankton can't grow efficiently, even if they receive sunlight and nitrogen. Many parts of the ocean depend on this airborne dust to fuel biological processes. This place, by contrast, sits too far from any strong dust sources. The nearest continents are distant enough that the dust settles long before reaching these waters. This combination of factors, nutrient scarcity, lack of mixing, stable atmosphere, and distant land, creates a region unusually resistant to biological growth. It's not a temporary condition. It has likely existed for thousands of years, shaped by the same currents that define it today. Even climate variations don't change it much. Temperatures rise and fall, weather systems shift, but the underlying structure of the gyre remains steady. That consistency means the area has probably been one of the ocean's emptiest zones for a very long time. What's interesting is how this emptiness affects the perception of the place. People often imagine remote areas filled with rare or unusual life, deep seas filled with giant squid, remote islands covered in unique birds, deserts with species adapted to harsh conditions. But here, the remoteness leads to fewer adaptations, not more. Most creatures that survive in extreme environments do so because those environments provide at least some benefit: unique resources, protection from predators, or access to specialized niches. This region offers none of those. It offers distance, but distance doesn't feed an ecosystem. Even microorganisms behave differently here. Some species drift through in low numbers, but their populations are limited by how few nutrients they have access to. Microbes that thrive in other places because they can multiply quickly remain rare here, because rapid reproduction is impossible without adequate resources. Viruses, bacteria, and other tiny forms of life all exist, but in quantities far smaller than in more active oceans. The emptiness becomes more apparent when you consider how much of the ocean is influenced by land. Coastal waters, even when far from civilization, receive nutrients washed in by rivers or stirred up by waves. Places near underwater mountains or ridges often contain unique ecosystems because the topography encourages mixing. But the central South Pacific has none of that. It's flat, open, and cut off from geological features that might bring nutrients upward. Even the seafloor here sits deeper than in many parts of the ocean, further limiting the chances for nutrient cycling. When scientists study global primary productivity, the rate at which phytoplankton converts sunlight into energy, this region consistently shows some of the lowest values, not just low compared to coastal waters, but low compared to almost anywhere else. It's a biological desert on a scale larger than many countries. The effect cascades through the entire ecosystem, thinning every level of life above it. It's worth noting that some animals still pass through. Migratory species sometimes cross these waters on long journeys. A turtle or whale might appear here by chance. A bird carried off course might rest briefly before continuing. But these appearances don't change the overall emptiness. They are moments, not patterns. The species that survive here long term are the ones adapted to low nutrient availability, but even they remain in small numbers. Because of the sparse life, the area also lacks the usual signs of predation, feeding, or surface disturbance. Near coastlines, fish break the water as they feed. Birds dive. Mammals surface to breathe or hunt. None of that happens frequently here. The ocean looks calm not because nothing ever happens, but because life remains too thin to create visible activity. It may seem strange that a place so open and seemingly inviting to sunlight could support so little. Sunlight alone doesn't drive ocean ecosystems. It must combine with nutrients to sustain life. Without both, energy flow collapses. The ocean becomes a large body of water with limited biological function near the surface. Another aspect often overlooked is how long water remains within this gyre. Currents circulate slowly, allowing the same body of water to remain in the system for years, even decades. over time, the water becomes increasingly depleted of nutrients as organisms consume what little exists. Because no new sources replenish it, the cycle becomes one of steady decline rather than growth. It's similar to living in a room with a limited supply of air and no ventilation. Eventually the oxygen diminishes. In the ocean's case, the nutrients diminish. Life slows to match what the environment can offer. All of this might make the area sound inhospitable or bleak, but the emptiness is simply the result of natural processes operating over enormous scales. The ocean isn't purposely barren here. It's just shaped by currents, distance, and chemical balances that leave little room for abundance. And that emptiness, far from making the region uninteresting, gives it a unique place in the world. It becomes a reference point for understanding how oceans work. It shows scientists what happens when conditions fail to support large ecosystems. It highlights the role of nutrients in shaping life across the planet. This low-life environment also explains why the region became a practical location for re-entering spacecraft. There is little biological activity to disturb, few animals to be harmed, no fishing grounds to impact. The water absorbs impacts without releasing harmful debris into areas where life is dense. It's not a graveyard in a dramatic sense. It's simply a place where the ocean's natural emptiness reduces risk. When you think about it more, the idea of nothing living here is a simplification. Life exists in microscopic forms, in deep-sea creatures adapted to low food supply, and in occasional visitors. But compared to the rest of the ocean, the difference is striking. The surface can feel almost devoid of movement. The deep sea can seem especially quiet, and the entire region feels like a vast space where everything drifts, but little settles or grows. All of these conditions link directly to what comes next, because this emptiness, shaped by scarcity and stability, sets the stage for how drifting objects, currents, and human-made debris behave in this part of the world, which leads naturally into the next step of our journey as we keep moving through the story without closing anything off. The emptiness surrounding this far-off part of the Pacific might make it seem like a place untouched by anything humans create, but the truth is a little stranger. Even though almost no one has ever travelled here, and even though the ocean holds almost no natural signs of life near the surface, it has quietly become one of the most human-influenced regions on Earth. Not because people live here, or fish here, or build anything here, but because over the decades, many things built for space have ended their journeys in these waters. It sounds unusual at first, a remote location filled mostly with drifting water, somehow becoming a resting place for machines that once orbited the planet. But it becomes clearer when you consider the practical challenges involved in returning large objects from space. Whenever a satellite or spacecraft reaches the end of its operational life, it needs to come down from orbit eventually. Space agencies have to make decisions about where these objects will land, because falling debris cannot simply drop anywhere. If a large structure returns uncontrolled, parts of it can survive the intense heat of re-entry. Those pieces can fall to the ground with enough force to cause damage. For safety, it's important to select a location where debris is unlikely to harm anyone or anything. That requires finding a large, empty region far from human activity, far from shipping routes, and far from land. And over time, this remote zone in the South Pacific fit all those criteria perfectly. Because this area has little to no traffic and almost no biological density, it became a practical solution. The history of placing spacecraft re-entries here stretches back several decades. Agencies from around the world recognized that this location minimized risk. It wasn't chosen because of some symbolic or dramatic reason. It was simply the safest place available in terms of distance from populated, inhabited, or ecologically sensitive areas. Over the years, this practical choice built a kind of unusual identity for the place. The first spacecraft deliberately guided into this region re-entered decades ago. What followed was a long series of missions that ended their lives here. These weren't just small machines. Some were large, heavy structures built to support scientific missions. Some were modules from orbital stations. Some were satellites that served essential communication or research roles. They orbited for years, sometimes decades, until they no longer functioned. Once their usefulness ended and their orbits decayed, they needed a place to return. When a spacecraft re-enters Earth's atmosphere, most of it burns up. The friction and heat generated by re-entry are intense enough to destroy the majority of the structure, but not everything disappears. Certain materials, especially heavier components, can survive. Engines, tanks, reinforced sections, and dense objects can make it to the surface. Because these pieces fall unpredictably during the final minutes of descent, scientists cannot guarantee that every fragment will land in precisely the same spot. That makes the surrounding emptiness of this region particularly useful. The nearest land is so far away that even if debris spreads out over hundreds of kilometers, it still remains well away from anything humans rely on. One of the most famous returns to this region was the controlled deorbit of a large space station that had spent years circling the planet. The station was carefully guided into the atmosphere, where most of it burned up. But the surviving pieces, including heavy metal components and structural sections, splashed into these waters. The event took years of planning. Engineers monitored the station's orbit, predicted its descent, and calculated the safest angle to bring it in. They knew that dropping it anywhere near land could pose risks, so this region's isolation became the natural choice. Many other spacecraft followed the same path. Some arrived as parts of larger vehicles. Some came as independent satellites that needed to be removed from orbit to reduce long-term space debris. Others belonged to different countries but still ended up here because all major agencies understood that the same rules applied. When you bring something down, you aim for the area least likely to be affected by what falls. Over time, people began referring to this region informally as a kind of oceanic disposal site for space equipment. Not because any deliberate structures are placed here, but because so many returns end up targeting these coordinates within a defined radius. It isn't a landfill in the traditional sense, it's more like a controlled impact zone. The debris doesn't accumulate at the surface. It doesn't form piles or clusters that people can see. Almost everything sinks quickly into deep water, settling across the seafloor, where currents are slow and stable. The ocean absorbs what arrives, and the pieces scatter over such a wide area that no single pile forms. If you could somehow see the bottom of the ocean here, you'd find scattered remnants separated by long stretches of sediment and stone. Some might rest upright. Others would have toppled over and half sunk into mud. Some would remain intact in recognizable shapes. Others would have broken apart during impact or while sinking. These objects sit quietly, undisturbed by currents strong enough to rearrange them. With so little life in the region, they remain untouched except by the slow processes of corrosion and pressure. These pieces aren't visible to ships or satellites. The water is far too deep, and the objects are too small relative to the scale of the seafloor, but they do exist, forming a kind of accidental museum of technology, scattered over an area much larger than any single crash site on land. Their presence speaks less about human neglect and more about the challenges of working in space. Every machine sent into orbit must eventually come down, and for many missions this region becomes the safest conclusion. It's unusual to think of a place with so little natural life becoming a final destination for machines built by dozens of countries. But the ocean's vastness makes it an effective buffer. No one hears the impacts. No one sees the splash except through instrumentation. No one watches the remnants drift downward, sinking into darkness. It's a quiet process that matches the quiet nature of the region itself. The idea of the ocean as a junkyard can sound careless, but in reality this practice involves careful planning, international guidelines and long discussions among engineers and experts. The aim is always safety, not convenience. Controlled re-entry ensures that debris doesn't fall unpredictably over land or populated seas. Whenever possible, space agencies attempt to deorbit objects in a way that maximizes atmospheric destruction. Only the heaviest or most heat-resistant fragments survive the descent, and those pieces are what finally reach the water. Some people imagine huge piles of metal resting beneath the surface, but that image doesn't match how the ocean actually distributes debris. The seafloor here is deep and uneven. Any objects that fall land far apart. They don't accumulate in neat stacks. Instead, each piece settles into its own resting place, separated by hundreds of meters or even kilometers of bare sediment. In that sense, the region holds countless small reminders of space missions rather than one concentrated collection. It's natural to wonder what condition these objects are in after years underwater. The pressure at these depths compresses anything with air inside. Metal corrodes slowly in cold, oxygen-poor conditions. Plastics remain longer, though most spacecraft use minimal plastics in structural components. Wiring, casing, brackets, and panels deteriorate gradually. Some might survive decades. Others might fade more quickly. Nothing down there remains untouched by the environment. Even in a region so empty, time eventually breaks everything into simpler forms. Even though the area contains remnants from many missions, it isn't considered an ecological hazard in the way shallow water dumping sites are. The primary reason is the extreme depth and low biological activity. There are few organisms to be affected, there is little nutrient cycling, and the materials arriving are mostly inert by the time they settle. Space agencies also follow international agreements that prevent the disposal of hazardous chemicals or active components. Fuel is burned off before re-entry. Batteries are discharged when possible. The aim is to minimize the possibility of environmental harm. Some of the most interesting stories connected to this region involve missions that failed in unexpected ways. Occasionally, a spacecraft loses control or communication before engineers can guide it. In those cases, scientists must rely on limited data to predict where it will fall. Often, they steer it as best they can toward this region, using automated systems or altering its orbit while communication still exists. These partial controls don't always create perfect descents, but they still reduce risk by ensuring that even uncontrolled falls occur near remote waters. In rare cases, debris from uncontrolled re-entries has fallen outside this region, but those events usually involve smaller objects or fragments. The larger, more dangerous missions are almost always guided toward the area because the stakes are higher. That includes cargo modules, orbital laboratories, and heavy satellites, objects that could cause serious damage if they landed near populated areas. As technology improves, space agencies attempt to design missions with safer end-of-life strategies. Some spacecraft are built to burn up completely. Others include systems that allow them to be pushed toward the atmosphere at specific angles. But even with these developments, the need for a safe ocean region remains. As long as humanity launches machines into orbit, there will be a need for a controlled place to bring them down. In a strange way, the region has become tied to human ambition. The same ocean that holds so little natural activity now contains markers of some of humanity's greatest achievements. Missions that explored the atmosphere, observed distant stars, mapped weather patterns, studied the Earth's surface, and supported astronauts in orbit. Their remains rest quietly beneath kilometers of water, forming a landscape only machines could populate. If someone could walk along the seafloor here, which of course isn't possible without specialized submersibles, they would move through a place filled with scattered reminders of human engineering. A piece of a heat shield, a twisted pipe, a fragment of solar panel, a broken housing for sensors, a metal ring that held two modules together. Each item tells a story about its journey from Earth to orbit and back again. But those stories remain silent. They sit where they landed, untouched, unobserved, part of a world where even the presence of these machines doesn't disturb the overall emptiness. It's important to remember that nothing about the ocean here signals what lies beneath. The surface gives no clue. The water looks the same as anywhere else in this region. The horizon stretches out with its usual calm. The wind moves without any hint that objects from space rest thousands of meters below. You could drift here for days without knowing that an entire history of orbital technology lies scattered across the bottom. That disconnect between what exists and what is visible makes the place unusual. It feels empty, yet it quietly holds the endpoints of missions that once circled Earth at thousands of kilometers per hour. In time, more spacecraft will likely return here. Even as technology evolves, the need for a safe re-entry zone remains. The emptiness of the region makes it uniquely suited for this purpose. The ocean doesn't show signs of change even as pieces of metal sink into its depths. Nothing accumulates on the surface. Nothing rises back up. The machines simply enter the atmosphere, burn, fall, and disappear into the deep. This unusual role leads naturally to the next part of the story, because the objects aren't the only things moving through these waters. The currents that define this region shape the motion of everything else that drifts here, natural and artificial, giving us more to explore as the narrative continues without closing anything off. When people hear that the most remote point in the ocean has become the final destination for spacecraft, they often imagine a dramatic scene beneath the surface, as if broken satellites lay piled together in the dark like relics in an underwater scrapyard. The reality is far less theatrical, but in some ways more compelling. These machines didn't fall here by accident. They were guided with precision, each one following a carefully calculated path through the atmosphere until only fragments survived the descent. Those fragments, travelling at high speed, struck the water and sank quickly, disappearing into depths that are not just hard to reach, but almost entirely beyond human exploration. If you picture the ocean floor in this region, it's useful to remember that it sits deeper than most parts of the Pacific. The depth varies somewhat, but it averages several thousand meters. At those depths, the pressure is immense, strong enough to crush hollow structures instantly. The darkness is absolute. Sunlight disappears long before reaching even a fraction of the distance to the bottom. Temperatures stay close to freezing, and the water barely moves, except for slow, creeping flows shaped by global circulation patterns. It's a world without much disturbance, a world where anything that settles tends to stay where it lands. The objects that end up here don't form a continuous field. They aren't clustered close together. They are spread out over a huge area, separated by long, empty stretches of seafloor. Some may be only small shards. Others might be pieces large enough to recognize even after years underwater. But none of them gather into anything resembling a graveyard in the traditional sense. The phrase spacecraft cemetery became part of popular language not because the area resembles a cemetery visually, but because it serves as the endpoint for so many missions. It's a practical description, not a literal one. Still, there is something haunting about the idea of all these machines drifting down into the deep. Some were once landmarks of technological achievement. They orbited Earth for years. They carried instruments that measured atmospheric conditions, radiation levels, magnetic fields, or geological activity. Some transmitted television signals. Others gathered climate data. A few held life support systems for astronauts. All of them represented enormous amounts of planning, engineering, and time, and eventually every one of them reached the end of its usefulness. Spacecraft aren't designed with graceful endings in mind. Their lifetimes depend on fuel reserves, orbital decay, structural fatigue, solar radiation, and the limitations of onboard electronics. Once a spacecraft can no longer remain functional or safe, the question becomes how to remove it from orbit in a way that doesn't create additional hazards. For larger objects, controlled descent is the safest option. That descent often ends here. Imagine a spacecraft orbiting Earth, slowly losing altitude. Each orbit takes it closer to the atmosphere. Engineers track its trajectory carefully. They make small adjustments using what fuel remains. Eventually, the craft encounters enough atmospheric resistance to begin heating. Panels break off. Insulation burns. Bolts melt. Electronics vaporize. The machine that once moved in the vacuum of space begins to tear apart under forces far stronger than those it experienced during launch. But even amid the destruction, not everything disappears. Heavier structures, like magnet assemblies, pressure vessels, engine housings, and thick metal components, can survive long enough to hit the surface. When the fragments strike the ocean, they produce splashes no one witnesses. The region is too remote for ships. No cameras record the impacts. No aircraft fly overhead to watch the descent. The event happens unseen, heard only by the machines tracking data from afar. The fragments then sink rapidly, pulled downward by gravity, entering a column of water so deep that it may take them hours to reach the bottom. As they sink, the water grows darker and colder. Pressure increases at a rate that would crush most human technology instantly. But many of the fragments are already ruined from the fall, their hollow structures compromised, their electronics destroyed, their casings dented or twisted. Only the densest pieces make the journey intact. Once they settle, they become part of the seafloor, resting in darkness where almost nothing lives. If you imagine someone descending in a submersible, the journey downward would feel almost unreal. The first hundreds of meters would still hold a pale glow from overhead. Then the light would fade until the world became completely dark except for whatever illumination the submersible carried. The water would be cold and still. No fish would pass by, no jellyfish would drift into view. The further you travelled, the more the water would feel like a place that had remained untouched for ages. Reaching the bottom, you wouldn't find wreckage everywhere. You might travel kilometres before encountering anything artificial. The first fragment you saw might be something small, like a piece of metal plating half buried in sediment, or a bracket covered in a thin layer of silt. You might find something larger, perhaps part of a cylindrical fuel tank or a section of a solar array twisted at odd angles. But these pieces wouldn't stand out dramatically. They would look like objects slowly losing their shape, pressed upon by time and environment. You wouldn't find bright colours or shiny surfaces. Almost everything would be dull, coated in a thin film of sediment. Some metal parts would look slightly corroded, depending on the alloys used. Plastics and composites might appear intact but faded. Ceramic materials might remain surprisingly recognisable, and everything would be surrounded by emptiness, stretching so far that the presence of these objects would feel almost accidental. None of these artifacts tell stories aloud, but they carry the history of missions that once circled the planet. A panel might come from a research satellite that mapped global temperatures. A tank could be the remains of a propulsion system used to keep a laboratory stable in orbit. A torn metal surface might have once held sensors that monitored lightning or storm patterns. The pieces themselves no longer function, yet they connect indirectly to decades of scientific progress. What's unusual about this region is that almost no one will ever see what lies on the sea floor. There's no practical reason to explore it directly. Research missions tend to focus on areas with biological value or geological interest, not the quiet sediment plains beneath an isolated patch of ocean. Even advanced submersibles often prioritize sites with active hydrothermal vents, unique ecosystems, or significant geological formations. This region doesn't offer those features, so the objects that fall here remain unobserved. Their presence doesn't alter the characteristics of the environment. The nutrient levels remain low. The biological activity stays minimal. The currents continue their slow patterns, unaffected by the small number of artificial objects resting at the bottom. Over the course of decades, corrosion slowly changes the shapes of metal surfaces. Pressure compresses internal cavities. Sediment gradually buries edges and corners. But these changes happen in a place without witnesses. Despite the quiet, the idea that so many machines share this final resting place has captured the public imagination. People talk about this region as if it contains ghosts of old spacecraft, not in a supernatural sense, but in the sense that remnants of once functional objects linger here in a form that echoes their former roles. The machines themselves aren't aware of anything, of course, but the concept of thousands of hours of human engineering effort ending in the same stretch of ocean gives the place a significance it wouldn't otherwise have. It becomes an endpoint not just geographically but symbolically, even though the environment itself remains indifferent. The term ghosts can also reflect the way these objects feel disconnected from their origins. Each spacecraft was built in a laboratory, handled by engineers, launched on rockets, monitored by teams of specialists, and used to gather important information. People watched their progress, managed their missions, and celebrated their successes. Once the mission ended, the object began its final descent into obscurity. When it splashed into the remote ocean, everything that connected it to human activity effectively ended. No one retrieves it. No one catalogues its final condition. No one examines the pieces. They simply become part of the deep sea's quiet landscape. Some of the most well-known objects brought down here include modules from large orbital complexes. One notable example was a station that had spent many years in orbit, hosting a wide range of experiments. It was large enough that engineers carefully planned its descent to minimize risk. Pieces of that station now rest somewhere along the sea floor, scattered across an area too large to survey in detail. The fragments serve as silent reminders of a program that once played a major role in space exploration. Other nations have contributed to the collection, either intentionally or through failed missions that required controlled descent. Weather satellites, communications platforms, navigation devices, scientific instruments, all have taken the same path through the atmosphere. What unites them is not their function, but their endpoint. They all return to the same quiet coordinates, or the region surrounding them. As the number of missions increases, the number of artificial objects reaching this area grows as well. Even though most fragments burn up completely, the heavier sections remain. The cumulative effect is a slow accumulation of human-made material scattered over a vast expanse. But it never creates a visible problem because the region is so enormous and the seafloor so deep. The amount of material is tiny compared to the size of the ocean. Some people worry that these remnants could one day cause environmental issues, but experts generally conclude that the impact remains minimal. Deep in the ocean, in a region with little biological activity, the fragments degrade slowly without affecting ecosystems significantly. The ocean has much larger challenges in other regions, near coasts in areas with heavy fishing, or where pollutants accumulate. Compared to those, the presence of these artificial objects is a minor concern. Still, it's natural to wonder about the future. As more spacecraft are launched, more will eventually need controlled re-entry. Engineers are developing ways to reduce the amount of debris that reaches the ocean. Some missions are built to burn completely. Others will use new technologies to deorbit more efficiently. But it's likely that this region will continue to serve as a primary destination for objects that survive re-entry. The idea of ghosts also ties into how people relate to things they can't see. Even though the fragments at the bottom of the ocean aren't visible, knowing they exist can create a sense of presence. People imagine what the seafloor looks like. They picture the shapes of objects distorted by pressure. They think about the missions those objects once supported. The imagination fills in details the eyes cannot see. There's a quiet irony in this. The most isolated place on the planet, known for its emptiness and lack of life, now contains remnants of human activity that have travelled farther than most people ever will. Objects launched into space, powered by complex technology, orbiting high above the Earth, eventually end up resting in a place where almost nothing else accumulates. It creates a subtle connection between the heights of human achievement and the depths of an environment shaped by absence. If someone could catalogue every object resting down there, they would produce a timeline of human spaceflight woven across sediment and rock. They would see older missions represented by small eroded pieces. They would see more recent ones in better condition. They might even find remnants from missions that people have forgotten. But cataloguing it is unlikely. The region is too deep, too remote, and too empty to attract that kind of exploration. As you think about all this, the descent, the impact, the settling, the quiet presence on the seafloor, The next part of the story takes shape, because while these objects rest in stillness, the water above them is shaped by currents that define how everything drifts in this region, linking the empty surface with the deep sea floor in ways that help explain the motion of the ocean surrounding it, giving us more to follow as we continue. When you look at a map of the Pacific Ocean, it's easy to see the empty space around this remote region and assume that the water simply sits still, waiting for something to disturb its surface. But that isn't how the ocean works. Even in the quietest places, the water is always moving. Not fast, not turbulently, but steadily. And in this part of the world, the movement follows a pattern so consistent that it gives the region much of its character. These currents don't rush across continents or break against rocky shores. Instead, they circle slowly, forming a kind of boundary that keeps everything inside the loop separate from the rest of the ocean. If you imagine the ocean as a giant network of rivers flowing without banks, this area sits within one of the calmest branches. The currents around it form what scientists call a gyre, a broad looping system shaped by wind patterns, Earth's rotation, and the geography of the surrounding continents. The South Pacific Gyre is among the largest on Earth, stretching across millions of square kilometres. Its flow is gentle but persistent, always rotating in the same direction, pushing water along in a slow circular motion that takes years to complete a single loop. This circular motion plays a major role in shaping the emptiness of the region. The water here doesn't mix much with water from outside the gyre. It stays within the loop, moving gradually around the centre. Because of this, nutrients rarely enter the region from other parts of the ocean. The same water keeps travelling in a closed circuit, becoming more depleted over time. That's why the surface remains so lifeless even though sunlight reaches it daily. If you picture a small floating object entering the gyre, you'll get a sense of how the currents behave. Something lightweight, like a piece of drifting material, would get caught in the rotation and carried around in a slow circle. It wouldn't travel in a straight line or move quickly toward land. It would remain suspended in the pattern, moving along the current lines with almost no variation. Over months or years, it would drift steadily but predictably, following the same paths that countless other objects follow. This motion has consequences beyond drifting debris. It affects the water's temperature, salinity, clarity, and chemistry. Because the circulation is so stable, the surface layer warms under the sun and remains on top. The deeper, colder water doesn't rise. The separation between layers becomes stronger over time, reducing the chance for mixing. That separation is known as stratification, and in this region it remains particularly strong. The surface layer may appear calm, but the stability below it is what prevents nutrients from reaching the organisms that could otherwise thrive here. The gyre also influences how the water interacts with the atmosphere. Winds blow across the surface, shaping waves and guiding the motion of the upper layer. These winds aren't chaotic. They tend to follow regular patterns created by temperature differences and Earth's rotation. The combination of wind and rotation keeps the gyre stable, preventing it from collapsing or shifting significantly from year to year. Even storms passing through don't change the structure much. They may churn the surface temporarily, but once they move on, the gyre returns to its usual motion. It's like a slow, predictable heartbeat within the ocean, beating at a rhythm far longer than humans naturally perceive. If you lived your entire life near the coast, you'd experience tides, waves, and seasonal changes constantly. Out here, the changes are subtle and often spread across months rather than days. This steadiness is part of why the region feels so detached from the rest of the world. Most ocean environments undergo regular disruptions. Seasonal upwelling, storms, temperature shifts, migrations of species. But in the central South Pacific, the environment remains more uniform. The water's colour stays the same most of the year. The clarity doesn't change much. Even the temperature remains relatively stable, shifting gradually rather than sharply. People sometimes imagine that the ocean's vastness must be chaotic, but in this region the predictability is striking. The currents don't slam into obstacles or collide with strong opposing forces. They just continue moving along their established paths. If something enters the gyre, whether organic or artificial, it becomes part of the system until something eventually removes it, either by sinking, breaking apart, or drifting out of the loop at an exceptionally slow rate. If you could watch the motion from above over many years, sped up so the slow patterns became visible, you'd see a broad rotation shaping the entire expanse. The edges of the gyre form its boundary, and the inner region remains calm by comparison. This calmness is not the surface-level calm that people feel when water is still, but a deeper kind: predictability of movement, stability of structure, consistency of flow. The phrase, "without touching anything," reflects the fact that the currents here don't interact with coastlines or continental shelves. In many parts of the world, currents strike land, redirect, split, and merge with other systems. But here, nothing interrupts them. They don't encounter islands or underwater plateaus that could break their motion. They don't interact with river output, which can dramatically change salinity or nutrient content. They don't collide with other gyres in ways that create turbulence. Instead, the entire region forms a kind of open lane for the water to travel through. This simplicity is one of the reasons the area remains so isolated from the rest of the world's oceans. Without interruptions, the water can circle indefinitely. Without mixing, the water becomes stagnant in a chemical sense. Not stagnant like a pond, but stagnant in terms of nutrient flow. Many oceanic environments need turbulence to support life. This region has very little. Different layers of water also move differently. The surface might drift one way, while slightly deeper layers move at different speeds. These differences don't create chaos. They form a gentle stacking effect, where each layer moves according to temperature and salinity. It's like a layered system without sharp contrasts. If you imagine dipping something into the water, a rope for example, you'd find that the surface current drags it noticeably, but the drag decreases as the rope sinks deeper. Within a few hundred meters, the motion becomes subtle. At several thousand meters, the movement becomes so slow that it barely registers. The deep ocean doesn't mirror the surface currents exactly, but its motion remains part of the overall system. Because of these currents, the region acts almost like a giant holding pattern. Debris, water masses, temperature anomalies all remain in the system longer than they do in other places. Even the chemical composition of the water reflects long-term isolation. Scientists studying this part of the Pacific often find consistent signatures in the water that indicate slow turnover. If someone could drift across the region with a simple instrument measuring currents, the readings would show long, smooth patterns rather than rapid changes. The strength of the flow varies with depth and season, but the direction rarely shifts dramatically. Over time, this creates a remarkable consistency in the environment. You might expect that such a predictable region would accumulate floating material, but the absence of nearby land prevents large amounts of debris from entering the system. The water stability also means that anything floating eventually breaks down under sunlight or sinks as it becomes waterlogged. Nothing really gathers here in the way some people imagine when thinking about ocean gyres. The more famous debris accumulations happen in other parts of the world, where wind patterns and human activity intersect differently. Here, the gyre is large, and the water is too empty of outside influences for debris to build up in concentrated amounts. The steady motion of the currents also makes the region important for studying global circulation. Even though it appears quiet, it plays a role in connecting different layers of the ocean. Water from other areas eventually cycles through this region, though the process can take decades or more. Because water remains here for so long, it can serve as a kind of reference point for long-term changes in temperature or chemistry. Scientists who examine these shifts often use samples from this region to understand how global oceans respond to climate variations. Another interesting aspect of the currents is how they distribute heat. The South Pacific Gyre helps move warm water across large distances, even if people don't feel the effects directly. It also influences weather patterns, not by creating storms, but by shaping the larger system that determines how heat and moisture move across the hemisphere. Changes in the gyre's motion, though subtle, can affect rainfall patterns on continents far away. The connection isn't immediate, but it exists over long timescales. If someone stood aboard a small vessel drifting in this region, the motion of the currents wouldn't feel dramatic. The surface waves might push the vessel slightly, but the direction of travel would be so slow and broad that the movement would be almost invisible. You might look over the side and see the water shifting past, but it wouldn't feel like a current in the way rivers create perceptible flow. It would feel more like gentle drifting, even though the motion covers thousands of kilometers over long periods. It's also worth considering how this stable environment interacts with the objects that fall from space. When spacecraft debris enters the ocean here, the currents don't scatter the fragments aggressively. The heaviest pieces sink to the bottom before the currents can move them far. The lighter fragments may drift slightly, but most eventually settle. Because the currents are steady rather than turbulent, the distribution of fragments remains relatively predictable, even though no detailed maps exist of their final positions. If you imagine floating above those deep waters, knowing what lies below, the currents might seem like slow ushers guiding everything that enters the region toward its eventual resting place. But that idea oversimplifies the process. The currents don't act with intention. They simply move as they always have, shaped by physics rather than purpose. The debris sinks not because the currents guide it, but because gravity pulls it downward faster than the water can carry it horizontally. Still, the region's stability ensures that the objects resting below remain where they are. There are no strong bottom currents to sweep them away, no underwater canyons to funnel them in specific directions, no geological features to trap them. They simply settle into the sediment and stay there. All of this contributes to the feeling that the region exists in a kind of suspended state. Not frozen, not motionless, but steady. Everything moves, but nothing pushes back. Everything drifts, but nothing forces change. The environment carries a sense of continuity that contrasts sharply with the dynamic systems found elsewhere. If someone stayed in this region long enough, they might begin to recognize subtle variations in the currents. Day to day, the differences would be small. Over months, the patterns might become slightly more pronounced. Over years, new water might enter the region slowly, replacing older water that finally exits the gyre. But these changes wouldn't stand out unless measured carefully. To the human senses, the environment would feel almost timeless. This slow, constant motion also connects directly to what comes next. Because while the currents circle steadily, the emptiness they preserve has shaped a long history of stories told by sailors, explorers and travellers who once crossed vast stretches of the ocean and formed impressions of places like this based on what they didn't see as much as what they did, giving us more to follow without closing anything off. When people imagine sailors crossing unfamiliar waters centuries ago, they often picture storms, towering waves, and dramatic encounters with landforms that were new to them. But much of the time, what sailors actually experienced was nothingness. Long stretches where water surrounded them in every direction. Days where the horizon never changed. Weeks where the sky and sea formed a pair of surfaces that felt almost identical. In places where the ocean was lively, they would at least see birds, floating debris, or a shifting coastline. But once their ships drifted far enough from land, especially into the vast Pacific, the emptiness became something many of them struggled to describe. For sailors used to coastlines or island chains, reaching the part of the world where the ocean seemed to stretch without interruption created a kind of tension. They relied heavily on visual cues for navigation, particularly before accurate instruments existed. With no landmarks, the ocean became a place where direction felt less certain. Even experienced navigators sometimes reported a sense of losing track of where they were. They knew their approximate latitude from the stars, but longitude remained difficult to measure accurately until much later. When the horizon offered nothing new for days at a time itself began to feel different. Many sailors kept journals during long voyages. Reading those journals today reveals patterns that repeat across generations of seafaring. When they travelled near coastlines, their writing focused on the landscape, the wind direction, the condition of the sails, the behaviour of birds and fish, and interactions with other ships. But when they crossed the Central Pacific, the entries changed. They became slower, more repetitive, and more focused on the monotony of the environment. Some wrote about the stillness of the water. Others noted how the sky seemed unusually large. A few described how the days blended together. Some accounts mention a feeling of disorientation, not from danger, but from the lack of reference points. Humans naturally anchor their perception of the world to boundaries, shorelines, buildings, mountain ranges, or even groups of clouds that stay visible for long periods. On land, it's rare to be surrounded by emptiness in all directions. Even in deserts, distant ridges or dunes create texture. But on the open ocean, especially in the Central Pacific, that texture often disappears. The water becomes smooth enough and repetitive enough that any sense of forward progress becomes harder to feel. Sailors often told stories about how the emptiness affected their thoughts. Some said the silence on calm days seemed louder than noise. Others wrote that they became overly aware of small sounds on the ship, the creak of wood, the flap of canvas, the shift of rope. Even the sound of the ocean brushing against the hull took on a different quality when there was nothing else to break up the ambient environment. These impressions weren't exaggerated. The Central Pacific is enormous, and long stretches of it contain no islands, no reefs, and almost no wildlife near the surface. The farther a ship sailed from land, the less likely the sailors were to see anything except the ship itself. In their journals, they sometimes wrote about small events simply because any event felt significant. A piece of drifting wood became interesting. A distant cloud formation became noticeable. A fish that jumped near the surface caught their attention immediately. The ocean didn't provide much stimulation, so the mind focused heavily on whatever small changes occurred. Before modern navigation tools existed, sailors relied on dead reckoning, celestial navigation, and wind patterns to maintain course. They watched the stars, tracked the sun's position, and used currents to predict where they were likely to drift. But in the Central Pacific, even the currents didn't provide dramatic guidance. They were steady but subtle. If you didn't pay close attention, you might drift slightly off course without realizing it. That uncertainty influenced many of the stories that circulated among sailors. Some spoke about ships that supposedly vanished into calm waters, not because of storms or conflict, but because they simply misjudged their routes and never located the land they expected to find. Many of those stories were embellished over time, passed down from one generation to another. But the core idea came from real concern. Without visible markers, a ship could easily drift off track by tens or hundreds of kilometres. If that ship relied on reaching land at a specific point, even a small error could lead to days of extra travel, causing shortages of water or food. Another recurring theme in sailors' stories involved the mental effect of empty horizons. Some described the horizon as wide enough to swallow thought. Others said it felt like sailing inside a circle without edges. These descriptions sound dramatic because they came from people attempting to express something unfamiliar. Most people before the age of global exploration never travelled far from their home coastal regions. For them, the world always contained boundaries. Forest edges, valleys, hills, and landmarks helped create a sense of place. Sailors entering the Central Pacific encountered an environment where place itself became difficult to define. It's important to remember that even though sailors today have precise maps and advanced tools, those earlier crews depended on experience and instinct. An instinct doesn't always apply well to a place with few cues. Many sailors likely underestimated how much that affected them. Their journals show attempts to stay focused on practical tasks, but they also reveal moments when the emptiness caused unease. Not fear exactly, but a kind of subtle pressure on the mind. Even seasoned captains experienced something like this. Some wrote that the stillness made it harder to judge weather. Without landmarks, distant storms could appear suddenly. Cloud formations at the edge of the horizon might be misinterpreted. Wind direction changes became harder to predict when the environment offered no visual hints. If a squall developed, it could sweep across the water quickly, catching sailors off guard. Despite these challenges, many sailors also found the emptiness calming. They described long stretches where nothing happened, where the sea rolled gently under the ship, and where the predictability of the environment gave them time to rest mentally. Some said the stillness allowed them to think more clearly. Others wrote that they enjoyed watching the sky change gradually over the course of the day. That mix of unease and calmness became part of the stories sailors told each other. On one voyage, a sailor might speak of endless blue horizons and quiet days that felt peaceful. On another, someone might recount how the emptiness made the crew restless. Neither story contradicted the other. The environment simply had different effects on different people. Some of the most interesting stories involved misinterpretations of natural phenomena. Sailors often looked for signs of land long before they actually reached it. In the Central Pacific, those signs rarely appeared. A piece of driftwood might have floated thousands of kilometers. A cloud shaped like a mountain might be just a cloud. A certain type of bird might fly far from its usual hunting grounds. These misleading signals sometimes created hope where none existed. When the hope faded, frustration set in. As a result, myths grew around certain stretches of the ocean. Not myths in the sense of fantastical creatures or supernatural forces, but myths about how the ocean behaved. Some sailors believed these waters could swallow ships without wind or waves. Others thought the currents played tricks, circling ships back to where they started without the crew realizing it. These stories weren't based on actual disappearances or anomalies, but on the psychological experience of travelling through an environment that didn't provide the usual feedback humans rely on. Even in the modern era, with accurate instruments and communication systems, sailors still talk about the strangeness of travelling through these waters. Not because navigation is difficult now, but because the environment feels unchanged. Cargo ships that cross this region occasionally report the same sense of distance and detachment that sailors felt centuries ago. The ocean still stretches without interruption. The sky still meets the water cleanly in every direction. The clarity and emptiness remain part of the experience. Some modern sailors describe how the horizon looks sharper here. Without land, moisture, or human-made structures interfering with visibility, the line between sea and sky becomes unusually well defined. That sharpness makes the world feel almost geometric. Others mention how the stars appear brighter at night. With no light pollution and no coastal haze, the sky becomes a wide field of visible detail. These impressions are consistent with what earlier sailors described, even though they lacked modern terminology. The stories that circulated among sailors also influenced how they prepared for long voyages. Knowing that they would face days or weeks without sighting land made them more cautious. They stored extra water, rationed supplies carefully, and watched the weather closely. Some ships travelled in groups for part of the journey, separating only when they approached their destinations. Others followed established routes to reduce the psychological strain of travelling too far from familiar waters. Even with careful planning, the isolation led to many narratives about unusual events. Some sailors thought they heard distant sounds on calm nights, even though no land or ships were nearby. Others believed they saw lights on the horizon, which later turned out to be stars rising or setting. Some claimed the water moved in patterns they couldn't explain, although most of those patterns were simply the natural behaviour of the gyre's slow circulation. As time passed and navigation improved, the practical concerns faded, but the stories remained. They became part of maritime culture, passed along not as warnings but as reflections on what it means to cross a part of the world where nature provides no obvious guidance. They emphasized the importance of patience, observation, and focus. They reminded sailors that even in a vast ocean, the mind can drift into unexpected places when the environment doesn't change. In recent decades, researchers studying sailor accounts have noted how consistent these impressions are. Even when the language varies, the themes remain the same: emptiness, stillness, distance. and the feeling that the world expands in every direction. These impressions align well with what science tells us about the region. The currents are slow, the biological activity is low, the visibility is high, and the nearest land lies far beyond the horizon. All of this forms a natural bridge into what comes next. Because the stories sailors told weren't only about what they saw or didn't see, but also about what the ocean revealed to them as they studied it more deeply. And understanding those stories leads into the scientific perspectives that help explain the nature of this region, giving us more to explore as we continue. Most people picture deserts as dry landscapes filled with sand, heat, and harsh sunlight, but in ocean science the word has a different meaning. It describes any part of the sea where life struggles because the basic ingredients for growth are missing. In this remote region of the Pacific, that description fits more accurately than anywhere else on the surface of Earth. The emptiness sailors described for centuries didn't come from imagination or exaggeration. It came from measurable factors that combine to create an environment where everything drifts, but very little thrives. When scientists study why certain parts of the ocean support abundant life, while others remain nearly empty, they look first at nutrients. Just like plants on land, the smallest organisms in the ocean need nitrogen, phosphorus, and trace metals to grow. These tiny organisms, especially phytoplankton, form the foundation of everything else in the marine food web. If their population is healthy, the entire chain above them grows stronger. If they struggle, everything else becomes sparse. In this central region of the Pacific, the concentration of these nutrients is extremely low. To understand why, it helps to picture the ocean as a layered system stacked vertically. At the top sits the sunlit layer where photosynthesis can happen. Below that is a deeper zone where sunlight fades, and below that a dark layer where almost nothing reaches from above. Phytoplankton exist in the sunlit layer, but they need nutrients that usually come from either land runoff or from deep water rising to the surface. In coastal areas, rivers carry nutrients into the sea constantly. In some open ocean regions, strong mixing occurs as wind and temperature changes push surface water downward and pull deeper water upward. But none of that happens here. The gyre that circles through this part of the Pacific traps surface water in place. It rotates slowly, creating a stable top layer that rarely mixes with the cooler, nutrient-rich water far below. Scientists call this stratification. It makes the surface layer warm and clear, but it also makes it poor in nutrients. The deeper water remains locked beneath a boundary layer that rarely breaks. As a result, phytoplankton can perform photosynthesis because they have sunlight, but they cannot grow abundantly because they lack the nutrients that allow them to multiply. When phytoplankton remains sparse, zooplankton remains sparse as well. These small drifting animals feed on phytoplankton. Without enough phytoplankton, they struggle to maintain large populations. Fish that feed on zooplankton do not gather here in significant numbers. Larger predators that rely on smaller fish avoid the area. Marine mammals pass through occasionally, but they do not linger because the food supply cannot sustain them. Even seabirds rarely travel this far from land because they rely on ecosystems where fish congregate. The emptiness sailors once described has a clear biological explanation. Scientists first began to map nutrient levels across the world's oceans during the 20th century. When they measured this part of the Pacific, they found concentrations of nitrogen and phosphorus that ranked among the lowest found anywhere. At first, this puzzled researchers. The ocean receives sunlight constantly, so it seemed logical to assume photosynthesis should thrive. But light alone is not enough. Without the necessary chemical building blocks, growth doesn't happen. This realization helped define the modern concept of ocean deserts, regions where sunlight exists but nutrients do not. Iron plays an interesting role as well. In many parts of the ocean, iron arrives through airborne dust blown from deserts on land or through underwater vents releasing minerals. But both of these sources are limited in this region. The nearest continents are too far to deliver dust effectively. Storms that carry iron-rich particles usually lose strength long before reaching this area. and the seafloor beneath this region lacks the volcanic activity that produces strong mineral upwellings. Without iron, phytoplankton cannot carry out certain chemical processes required for growth. This combination of low nitrogen, low phosphorus, and low iron creates an environment where phytoplankton grow only at rates far below those seen in other parts of the ocean. They survive, but they do not flourish. Their limited growth becomes the controlling factor for everything above them in the food web. Temperature also plays a role. The surface water here warms under constant sunlight, and because the region sits within a stable atmospheric system, that heat accumulates. Warm water is lighter than cold water, so it stays at the top. The deeper water remains colder and heavier. The separation between these layers becomes strong enough that mixing rarely happens. In regions near the equator or along coastlines, winds and currents break this separation. But in this part of the Pacific, the balance of forces maintains the structure year-round. When scientists measure the depth of the thermocline, the boundary between warm and cold water, they find that it sits firmly in place, acting like a lid on the deeper layers. That lid prevents nutrients from rising to the surface. Without mixing, the surface water becomes increasingly clear and nutrient poor over time. The deeper water, though rich in nutrients, remains inaccessible to the organisms that rely on sunlight. This layered structure creates a consistent pattern across the region. When ships pass through and take water samples, the results show remarkable uniformity. Low chlorophyll levels, low nitrogen, low phosphorus, and minimal biological activity. Even satellite measurements of ocean colour confirm this. The water appears more blue than green, indicating very low concentrations of phytoplankton. From space, this region looks like a long, calm patch in the ocean's surface, lacking the biological patterns that other regions display. One reason scientists call this region an ocean desert is that the biological productivity is comparable to some of the most nutrient-poor land deserts. Even though water surrounds everything, the limitation isn't moisture, it's chemistry. Life needs the right chemical environment to grow. Here, that environment simply doesn't exist in sufficient quantity. The influence of the gyre extends beyond nutrient availability. The movement of the water shapes how particles travel. In productive regions, dead phytoplankton and other organic material drift downward, feeding deep-sea ecosystems. In this region, the downward flow is small. The deep sea receives only a thin supply of organic matter. As a result, the organisms in the deep must survive on extremely limited resources. Some species adapt by slowing their metabolism to conserve energy. Others rely on unusual survival strategies. But overall, the deep-sea environment beneath an ocean desert reflects the scarcity above. Changes in global climate patterns also affect this region in subtle ways. As temperatures rise, stratification often becomes stronger. Warm water becomes lighter, making it even harder for deeper water to rise. That can reduce nutrient mixing even further. Scientists studying long-term trends have observed that oligotrophic regions like this one are expanding in some areas. If that pattern continues, parts of the world's oceans may see decreased productivity over the coming decades. Understanding places like this one helps researchers model how global systems might change. The region also provides insight into how the ocean absorbs carbon. Phytoplankton play a major role in removing carbon dioxide from the atmosphere. When they photosynthesize, they take in carbon. When they die, some of that carbon sinks to the deep ocean. But in regions where phytoplankton remains sparse, the ocean absorbs less carbon biologically. The ocean can still absorb carbon chemically, but the biological pathway is weaker. By studying how little carbon uptake occurs here, scientists learn about the limits of the ocean's natural ability to balance atmospheric carbon dioxide. Despite the emptiness, the region remains important scientifically. It serves as a baseline for understanding how much life the ocean can support under minimal conditions. Researchers often compare highly productive regions, like upwelling zones near continents, to this region to see how nutrient availability influences every level of the ecosystem. When scientists deploy instruments here, they often measure chemical changes that occur only very slowly. Because the region is so stable, it helps reveal long-term trends that might be hard to detect in more dynamic environments. Another important factor is the clarity of the water. In many parts of the ocean, sunlight doesn't penetrate deeply because particles or microorganisms block it. Here, the clarity allows sunlight to reach unusually deep levels. But this doesn't help productivity much, because phytoplankton still need nutrients to grow. Instead, this deeper light penetration affects temperature structure, contributing to the strong stratification. It also allows certain types of specialized organisms to survive at greater depth than usual, but these organisms have limited impact on the overall ecosystem. Modern instruments allow scientists to measure tiny variations in temperature, salinity, and chemical composition. These tools reveal that while the region appears uniform, it still experiences subtle changes over long timescales. Seasonal shifts can slightly alter the depth of the thermocline. Atmospheric conditions can influence surface temperatures, but none of these changes significantly increase nutrient availability. The region remains one of the least productive parts of the world's oceans year after year. The lack of productivity doesn't mean the region lacks scientific value. On the contrary, studying a place defined by scarcity helps researchers understand the limits of biological resilience. It also helps them identify how different ecosystems respond to low-nutrient environments. Some organisms adapt by becoming extremely efficient at using tiny amounts of nutrients. Others drift in and out of the region depending on ocean conditions. Tracking these adaptations helps scientists learn how life persists in challenging environments. Some researchers are also interested in how this region interacts with global circulation. Because the surface water remains in the gyre for long periods, it serves as a kind of reservoir containing specific chemical signatures. These signatures can help scientists understand how water masses move across the Pacific. When water eventually leaves the gyre, it carries those chemical markers with it. Tracking them reveals long-term patterns in ocean circulation that are otherwise difficult to observe. The clarity and stability of the water also make the region valuable for calibrating instruments. Satellites that measure ocean color or temperature often use this region as a reference point. Because the conditions remain so consistent, scientists can compare satellite readings to in situ measurements and adjust their systems accordingly. The region's uniformity becomes a practical tool for monitoring the health of oceans globally. While all of this scientific understanding provides clarity, it also reinforces the idea that this region is defined by what it lacks rather than what it holds. There's no dramatic upwelling, no blooming plankton, no bustling food webs. The sea appears almost unchanged from one day to the next. Most of the motion comes from slow currents that circle quietly. Most of the life exists in small quantities, and most of the changes happen so gradually that only long-term measurements reveal them. This scientific perspective ties naturally into what comes next. Because understanding the emptiness, from nutrients to currents to deep-sea scarcity, helps explain why people often imagine that something unusual might hide in such a quiet place. And that leads us directly toward the next part of the story without closing anything off. When people hear that there is a point in the ocean farther from land than anywhere else on Earth, they often begin wondering what could exist there simply because the place feels so removed from everything familiar. Even when they learn that the waters hold almost no life, that the seafloor is scattered with fragments of old spacecraft, and that the currents keep the environment calm and stable, their curiosity doesn't disappear. The combination of emptiness and isolation encourages imagination. Human beings naturally wonder what might exist in places that seem quiet or unexplored, even when science explains most of what happens there. For many people, the idea of a location so remote produces questions about whether something unusual might inhabit the deep. A creature not yet discovered, a form of life adapted to scarcity, or a species that remains hidden because nothing draws attention to it. These thoughts don't come from a belief that the ocean hides secrets deliberately. They come from the simple fact that very few people have seen these waters directly, and even fewer have explored the deep sea beneath them. When a place remains unobserved, the lack of information often feels like an invitation to imagine what might be there. But the quietness of this region doesn't imply the presence of hidden creatures. It results from limitations that leave very little room for complex ecosystems. The conditions needed to support large animals, plentiful food, dynamic mixing, strong circulation, and stable populations don't exist here. The environment isn't rich enough to support large organisms over long periods. Any creature travelling through would quickly realise that the region cannot sustain it. So the idea of large, undiscovered species living here long-term does not align with the biology of the place. Still, people continue to imagine possibilities. Part of that comes from the simple fact that humans have uncovered so many unusual species in better studied parts of the deep ocean. Strange fish with transparent bodies, animals that produce their own light, organisms that thrive around hydrothermal vents, and creatures adapted to crushing pressure all demonstrate how diverse life can be in the right conditions. It's natural to think that if unusual life exists elsewhere, it might also exist in the most remote region on Earth. But what sets this region apart is that the deep sea here does not receive the same influx of energy or nutrients that other deep sea environments benefit from. Around hydrothermal vents, minerals from the Earth's crust support ecosystems built around chemical energy. Along continental shelves, sediments and sinking organic matter feed large communities. In the Central Pacific, however, the lack of organic material from above limits the size and diversity of deep-sea populations. The organisms that live in these depths are likely similar to those found in other low-nutrient deep-sea regions, slow-moving, energy-efficient species that survive by conserving resources. The deep sea always holds possibilities for discovery, but in this particular area, those possibilities are shaped by the same constraints that limit surface life. Any undiscovered species would almost certainly be small, sparse, and adapted to extreme scarcity. They wouldn't resemble large or dramatic forms of life. They would fit the environment's limitations, matching the conditions rather than contradicting them. Even with that understanding, people imagine the quiet holding something extraordinary because they equate remoteness with mystery. Many stories throughout history associate distant places with the unknown. When explorers reach the edges of their maps, they often filled the blank areas with thoughts about what might lie beyond. This tendency hasn't disappeared. Even today, many people feel drawn to the idea that something unusual could exist where few eyes have looked. When someone hears that the ocean around this remote point stretches for thousands of kilometers without interruption, their mind may picture enormous stretches of blue water hiding something just out of view. It doesn't matter that science explains the scarcity. The idea itself feels open-ended. People wonder whether the emptiness is only on the surface or whether something deeper remains unnoticed. They imagine creatures that rarely appear because they have no need to interact with the surface. They imagine species that move slowly, blending into the dark, living within the deep layers that rarely receive attention. But the deep sea here differs from regions where dramatic discoveries historically occur. The hydrothermal vent communities discovered decades ago were located in areas where geological activity pumps chemicals into the water, creating unique habitats. The large predators encountered in other parts of the Pacific are drawn to regions rich in prey. The unusual jellyfish or transparent fish found elsewhere appear in zones where nutrients and currents create niches for them. This region lacks all of those features. It provides no energy sources beyond the thin supply of organic matter that sinks slowly from the surface. That supply is too small to support large or fast-moving species. Even the pressure at these depths does not create new possibilities. Pressure alone doesn't generate life. It simply determines which organisms can survive physically. Food availability remains the most important factor, and here, food availability is extremely limited. So while the deep sea always holds potential for discovery, the discoveries in this part of the ocean would almost certainly reflect the sparse, low-energy system that defines the entire region. People also imagine hidden things here because the place contains the remnants of old spacecraft. Knowing that machines built by humans rest on the seafloor sparks curiosity about what else might rest there. If objects no longer visible at the surface populate the bottom, perhaps something else could too. But the fragments lying on the seafloor aren't mysterious. Their presence is the result of a clear and well-understood process, controlled re-entry designed to minimize risk. Nothing about their existence suggests the presence of anything unexplained. They simply sit where they fell, separated by huge distances and slowly affected by time. Another reason people imagine hidden possibilities is the region's lack of noise. Many environments produce sound, waves crashing against cliffs, animals vocalizing, wind moving across land. Here, the quietness gives the impression that something might exist beyond hearing. But quietness doesn't imply secrecy. It simply reflects the lack of life, the stable atmosphere, and the absence of dramatic events. The conditions that create the silence are the same conditions that limit the environment's ability to support anything unusual. When scientists deploy microphones in the deep sea, they record many forms of sound: whale calls, seismic activity, distant storms, and even human-made noises from ships. But in this region, recordings often capture very little. The lack of biological activity means fewer natural sounds. The distance from major shipping routes reduces mechanical noise, and the stability of the water eliminates many types of turbulence. The recordings reflect the environment accurately: quiet, empty, uneventful. It's understandable that people feel the need to fill that quietness mentally. Humans rarely encounter places where almost nothing happens. On land, even remote deserts contain signs of life: plants, insects, reptiles, birds, and mammals adapted to the climate. But in this part of the ocean, the emptiness spans kilometers vertically and horizontally. That level of absence isn't common in nature, so people naturally wonder whether the quiet conceals something. Curiosity also comes from popular culture. Stories about the deep ocean often involve hidden creatures, unexplored worlds, or unusual environments. These stories encourage people to imagine possibilities, even when those possibilities don't match scientific understanding. When someone hears that more people have been to the moon than to the seafloor at these depths, they may assume that something about the seafloor remains unknown simply because it hasn't been observed. But the lack of observation doesn't imply complexity. It simply reflects logistical challenges. Deep-sea exploration is expensive, time-consuming, and usually focused on regions with specific research value. A nutrient-poor sediment plain doesn't attract much attention, not because it hides secrets, but because scientists already understand most of what exists there. Even so, imagination fills the space that science doesn't occupy directly. Someone might wonder whether unusual geological formations exist there, but geological activity is minimal in this region. The seafloor consists mostly of sediment, with occasional ridges and slopes formed by tectonic processes long ago. There are no vents, no mineral-rich fissures, and no active volcanic features. The environment is stable, cold, and dark, offering little variation from place to place. People might also imagine submerged structures or relics left by ancient civilizations. This idea appears often in fictional stories, but it has no basis in geological or archaeological evidence. Human civilizations developed along coastlines, rivers, and fertile valleys. They didn't have the means or reasons to build structures thousands of kilometers offshore in deep water. Nothing about this region suggests any human-built object existed here before the space age. Some imagine wrecked ships resting on the sea floor, but historical trade routes rarely passed through this region. Ships typically followed paths close to land or along established currents where they could resupply, find shelter, or follow predictable winds. The Central Pacific's emptiness made it an unlikely place for ships to travel before modern navigation. While occasional drifting debris or accidental losses may have occurred, the region does not contain the large shipwreck sites found elsewhere, Others imagine meteorites landing here because the region covers a wide expanse of water. While meteorites do fall into the ocean regularly, the chance that many of them land in this specific small region is low simply because the ocean is enormous. Meteorites are scattered randomly across the planet. There is no reason to believe that any significant number accumulated here. The imagination surrounding this region reflects human tendencies more than environmental reality. People often treat unexplored spaces as if they invite possibilities, but here the conditions shape those possibilities into narrow forms. The quietness is not protective. The emptiness is not intentional. The isolation is not symbolic. It is simply the result of natural processes that create a low-nutrient, low-energy, stable environment. Even with all the scientific explanations, imagining what might exist in the quiet isn't harmful. Curiosity encourages exploration. It fuels scientific questions. It inspires people to learn more about the ocean. But it's important to balance curiosity with the understanding that environments follow physical rules. Nothing about the region prevents life from existing. It simply provides so little energy that only sparse and simple forms of life can survive there. People sometimes ask whether the emptiness could hide new species of microorganisms. That possibility always exists because microorganisms evolve quickly and adapt to different chemical environments. But any new species discovered here would resemble other deep-sea microorganisms, small, slow-growing, and tuned to limited resources. They would not represent dramatic departures from known forms of life. Their discovery would expand scientific knowledge, but not transform the understanding of the region. The same applies to any undiscovered geological or chemical feature. Small variations might exist, slightly elevated seafloor sections, small depressions, or differences in sediment composition, but nothing suggests the presence of unique structures or phenomena. The region remains quiet, not because it conceals something, but because nothing introduces energy into it. If someone travelled across this region with advanced equipment, they would likely record the same patterns scientists already observe: stable temperatures, low nutrient levels, clear water, minimal biological activity, and predictable currents. The equipment might detect small fluctuations, but the overall picture would remain one of uniformity. This leads naturally toward what comes next, because once the imagination settles and the scientific understanding becomes clear, the final step is to consider how this quietness affects the way people experience the world when thinking about remote places like this one. And that continues gently into the concluding part of the journey without closing anything off. Reaching the end of this long path across the most distant part of the ocean brings a different kind of quiet than the one that defines the region itself. This quiet comes from finally gathering all the pieces together. The emptiness, the drifting currents, the stories told by travellers, the machines resting below, the biology shaped by scarcity, and the distance that makes the place feel separate from almost everything else in the world. When all of those threads settle side by side, the picture becomes clearer. The region isn't strange because of something hidden within it. It's unusual because of how little influences it, how little reaches it, and how little it needs to remain exactly what it is. If you imagine yourself drifting across those waters, not in a rush, not looking for anything specific, just letting the world around you exist as it is, you might begin to notice how different the experience feels compared to other places. There are no landmarks to watch as they fade behind you, no landmarks ahead to mark your progress. The horizon doesn't shift. The waves don't break in sudden patterns. Everything feels steady, as though the world has paused for a moment to show a place where change happens slowly. Being present in that kind of environment shapes the way the mind works. The focus shifts from expecting new sights to observing what remains constant. The air would feel similar to any other place on the open ocean, clean, cool, and shaped by the slow movement of distant winds, but without much variation to draw your attention. The water would roll beneath whatever carries you, gently enough to feel predictable. Even if the waves rose slightly, the motion would still reflect the general calmness of the region. The sky might form a broad, pale stretch during the day or open fully at night, revealing more stars than most people ever see at once. But none of these details would demand attention. They would simply exist, steady and unhurried. If you listened carefully, the sounds around you would likely blend together into an even tone. The wind moving across the surface, the water tapping lightly against whatever structure rests on it, the occasional movement of ropes or materials shifting in response to the waves. These sounds wouldn't rise or fall sharply. They wouldn't break into harsh rhythms. They would continue at a quiet, even pace that encourages the mind to slow down. And in that slowed state, the region begins to feel less like empty space and more like a part of the planet, designed to show what the world looks like when nothing demands attention. It's rare to find environments that don't compete for focus. Most places present patterns, colours, motions and changes that affect the way you think. But here, the absence of those details contributes to a different experience. It creates room for thoughts to settle without being pushed from one moment to the next. Travellers who crossed this part of the world long ago described the same effect in their journals. They wrote about how the emptiness gave them time to reflect, how the predictability of the waves made each day feel similar to the last, how the spread of water that never changed direction encouraged long stretches of thought. Even when they didn't have modern scientific explanations for what shaped the region, they sensed something about the place that slowed time for them in a noticeable way. Today those impressions blend with scientific understanding. The stability of the gyre prevents dramatic changes in the surface water. The low biological activity limits the appearance of animals. The long distance from land removes the usual environmental cues that shape coastal experiences. When these factors combine, they create a space where the world feels still, even though everything remains in motion. People often expect oceans to be dynamic and full of activity. They picture storms rolling across the water, waves rising and collapsing, or animals moving in large groups. But this part of the Pacific rarely reflects those expectations. The activity happening here occurs at scales too slow or too subtle for casual observation. The currents flowing thousands of kilometres, the tiny exchanges of nutrients between water layers, the gradual sinking of particles through the deep, the quiet descent of old spacecraft fragments into the darkness. None of these movements appear at the surface in ways a person would notice without scientific tools. And yet, despite the stillness, the region remains part of the world's larger system. Water flowing through the gyre eventually moves elsewhere. Heat absorbed at the surface influences atmospheric patterns far away. Even the quiet biological activity contributes to global cycles in small but measurable ways. The region isn't disconnected. It simply operates at a pace and scale that hides its influence behind slow, steady processes. If you continue drifting, not just for a moment but long enough to let the experience settle, you might begin to understand why people sometimes imagine this place as the edge of the map. Not because it marks a boundary in any literal sense, but because it feels detached from the usual rhythms of the world. Standing here leaves a person with the sense that they've reached a point where familiar patterns fall away. There is nothing here to compare with coastal environments, nothing to match the layered energy of busier seas, nothing to reflect human presence. The region doesn't seem like the edge because it ends something. It feels like the edge because it doesn't begin anything. It simply continues. The idea of a place continuing rather than beginning or ending shapes the way the mind processes it. When you look at land, you see shapes that define boundaries. When you travel through cities, you experience constant change. When you walk through forests, you notice layers of life interacting. But here, the lack of those features removes the need to interpret new information every moment. Instead, the focus drifts toward observing consistency. People sometimes use the word nowhere to describe places far from human activity. But this region doesn't really fit that description. It isn't nowhere. It's part of Earth's largest ocean, shaped by forces that existed long before people ever learned to cross it. What makes it unusual isn't that it lacks meaning, but that its meaning isn't tied to human experience. It's a place defined entirely by natural processes that operate without concern for how humans perceive them. If you thought about the seafloor beneath you while drifting here, the contrast between the surface and the depths becomes clear. The surface shows almost no sign of what lies below. The deep, cold water holds fragments of old machines that once orbited the planet, scattered across the bottom in silence. They sit there without changing the environment around them. They don't form clusters or affect ecosystems. They simply rest where they fell, slowly breaking down over time. If anything feels unusual about that, it's not the presence of the fragments, but the scale of the emptiness surrounding them. This region, shaped by distance and slow motion, doesn't hide much. The lack of energy limits what exists here naturally. The stability of the water prevents sudden changes. The scarcity of nutrients ensures that life remains thin. All of these factors strip away the complexities seen in other parts of the world, leaving behind an environment that offers a different perspective on what the ocean can be. If someone stayed long enough, they might begin to notice small variations that don't appear at first. The slight shift in the colour of the water as the angle of the sun changes. The steady movement of the swells aligning themselves with the wind. The faint differences in temperature between day and night. These small details don't break the overall impression of steadiness, but they add depth to the experience, showing that even quiet places hold subtle signs of change when you pay attention. Some people might think that nothing meaningful comes from drifting across such an empty region. But the quiet itself creates meaning by offering contrast. When you spend enough time in a place where movement, sound, and complexity remain minimal, you become more aware of those things when you encounter them again. The mind adjusts its scale. The absence of loud or fast patterns makes subtle ones easier to appreciate. This idea appears often in the journals of sailors who crossed remote waters. After weeks of emptiness, they noticed the smallest details when they finally approached land. A bird flying overhead, a patch of seaweed near the surface, a change in the scent of the air. These details carried more impact because of the contrast. The region they crossed gave them time to slow their minds, and that slowing affected how they perceived everything afterward. Modern travellers, even with all the conveniences of navigation and communication, experience something similar if they spend time in calm, open waters. The world feels larger and quieter, even if they know precisely where they are. The experience becomes less about reaching a destination and more about observing how the planet behaves when it isn't shaped by human structures. It becomes a reminder that much of Earth still operates independently of human activity. If you think about that feeling while floating near this remote point, the place starts to resemble something less like a boundary and more like a pause. A place where the pace of the world slows enough to let you consider what you've seen, what you've learned, or what you're still thinking about. A place that doesn't offer dramatic views or striking features, but instead gives you time and space to settle your thoughts. Even though this region is far from land, the water beneath you remains connected to every other ocean on the planet through slow circulation. Eventually the water here will move elsewhere, carrying a record of its time within the gyre. Over decades, the surface layer will shift. The deeper water will circulate through other regions, and the chemical signatures will spread. The region doesn't remain unchanged forever. It simply moves at a pace that makes change impossible to see from one moment to the next. As you drift, you might notice how the mind begins to mirror the environment. The lack of sudden movement encourages slower thought. The distance encourages longer, uninterrupted reflections. The stillness allows small details to stand out. That's why people often describe feeling a sense of calm when imagining places like this. The environment doesn't create that feeling intentionally, it just removes the distractions that usually compete for attention. If you stayed long enough, the sense of being at the edge of the map might shift. It might become less about the idea of a boundary and more about recognizing how the world looks, where none of the usual signals guide your expectations. You might stop thinking about direction entirely. You might stop wondering how far away land is. You might stop expecting the environment to change. Instead, you might find yourself simply observing what surrounds you, letting each moment unfold without looking ahead or behind. The calmness of the region creates a space where thoughts have room to spread out. The slow movement of the water sets a rhythm that is easy to follow. The absence of noise allows the mind to settle, and all of this makes it easier to drift, not just physically across the surface, but mentally toward a place of rest, shaped not by anything dramatic, but by the steady quietness of the world's most remote waters. The journey across this region doesn't come to an abrupt end. It doesn't conclude with a sudden shift in scenery or a dramatic realization. It simply continues, the way the water continues to move through the gyre, the way the horizon continues to hold its shape, the way the quiet continues to settle softly around everything. Remaining here for a moment longer, or letting yourself drift toward the next place, both feel natural, because nothing in the environment demands one choice over the other. The world remains open, steady and unhurried, carrying you gently toward whatever comes next with the same calmness that has shaped everything you've seen so far.